হ্যালো 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 ঠিক আছে।
We are requesting our students to please be seated. Good morning and welcome to the second day of the 5th annual conference Mcccon 2024 on functional food as dietary intervention for chronic diseases, organized by Midnapore City College. Yesterday was a wonderful and enriching day for us with all our delegates. Today we will have more of the sessions with our honored and esteemed speakers.
A very good morning to everyone. Today we have the enlightening lectures of eminent professors like Dr. Anil Kumar Anol, Dr. Madhumita Borua and Dr. Dept Bhattacharya. Now it's time for the technical session 2. It will be chaired by Professor Nirmal Kumar Sarkar, former professors of Biological Sciences, Presidency University, Kolkata, and Emeritus Professor, Department of Biological Sciences, Midnapore City College. Sir, please take your seat on the stage and see he will chair the session. Over to you, sir.
Dear friends, it is time to start the technical session of day 2 of this conference. We are lucky enough to have amongst us 3 eminent scientists today as invited speakers. They are Professor Anil Kumar Anal from Asian Institute of Technology of Thailand, Professor Madhumita Borua from Assam Agricultural University, and Dr. Dept Bhattacharya from ICMR Regional Medical Center at Bhubaneswar. The first speech will be delivered by Professor Anil Kumar Anal. Before that, I would request students to give a big round of applause for Professor Anil Kumar Anal. Now I request another round of big applause for Professor Madhumita Borua. And definitely the third round of applause goes for Dr. Dept Bhattacharya. With this brief prelude, I invite on behalf of all people of this college, Professor Anil Kumar Anal to kindly come to this dais. It is customary that I introduce the learned speaker to you all before he starts his valuable deliberations. Professor Anil Kumar Anal is Professor cum Chair of the Food Innovation, Nutrition and Health Program in the Department of Food Agriculture and Bioresources in the Asian Institute of Technology of Thailand. Professor Anal has been featured as the top 1% scientist globally in the field of food science. The arena of research of Professor Anal circles around traditional and underutilized local food products, green technology-based valorization of agro-residues, biomolecular interactions and their applications in food systems, designer diets for enhanced health benefits, and nanotechnology-based delivery systems for bioactive molecules. Professor Anal has conducted various innovative research and consultancy projects related to sustainable and safer food production systems. Professor Anal had notable research experience in Otago University and Massey University of New Zealand. Professor Anal is, simply speaking, a giant in the field of research. He has more than 200 research paper publications to his credit, along with authorship of 60+ textbook chapters, 10 edited volumes, and 7 international patents. Professor Anal has supervised a number of research projects funded by different international agencies like Newton Fund through British High Commission, Asian Development Bank, Thailand Graduate Institute of Science and Technology, Global Challenges Research Fund, etc. It goes without saying that Professor Anal has played the role of keynote speaker and resource person in numerous international and national conferences and workshops. He has been serving as editor, associate editor, and member of editorial board of many international peer-reviewed journals. Moreover, he plays the role of academics, research advisor, and consultant in various countries like India, Nepal, Bangladesh, Thailand, Japan, Vietnam, Spain, Germany, Austria, and New Zealand. Professor Anal is also the owner of a number of awards. I skip the list. Excuse me, sir. It may take a long time to complete to highlight your biodata. Professor Anal has kindly consented to enrich us with his deliberations today on immunomodulation and enhancing the immunity, unveiling the potential of designer diets. Welcome, sir, for giving your speech.
It's okay. I can do it. I think that's better. Thank you very much, Chair, for a nice introduction. And a very good morning to all of you present. I have been witnessing since yesterday. Let me first thanks to organizer for giving this opportunity to come and share the thoughts, participating with you, getting the knowledge. That's the purpose of going around and learning more from the students, from the faculties, young faculty, senior faculties, professors, researchers, all this. This is our aim. So learning is never ending, and that's we aim as well. So it is very pleasant to be here. Actually, just last month I was in another conference in Calcutta, which was on the food science and technology, organized by ICAR and other universities there. So it is again to be back here. Very happy to be along with you all. I hope yesterday was the big day, and there were a lot of informations we learned, and the evening was beautiful as well. So many congratulations to the organizing team and all the organizers here having such a successful and this conference, and I wish much more on this one. So with that note, I would like to start my talk. You already know about me. I mean, that's the academics, and like yesterday one of our speaker was mentioning, whatever we are not ourselves. It's all our students' credentials actually, or the researchers working in the lab with us. So that's there. By now, I think I will not acknowledge later, but I acknowledge now all my students, especially in last 13, 14 years of career in my AIT. I already graduated 27 PhD students, so they deserve more actually for all credentials. 15 are working in my lab currently as a PhD, and more than 130 master students. And those are not from the one place, it is all over the, I can say now even I have one student working from the US in my lab as a master student. Couple of them are from the Europe, France, and Germany as well. Obviously from India, Nepal, Bangladesh, all those countries are there. So this is all diverse, and I learn from them a lot, and that gives me a lot of opportunity. So I always acknowledge before I say anything to them, and like you students always do the good job, and that helps your advisor or professors to grow as well. Briefly, I go from there to my talk. I will just share a couple of slides for my institute. As mentioned, I belong to Asian Institute of Technology, based in Thailand. And this is only postgraduate institutions. Means we don't have too many, I don't say young children like undergraduate students. We say that when you come to the postgraduate, you are matured students, and that's we are lucky to have those matured students with us. So it's all we have in different departments, schools, 3 schools. So we have around 17 to 1800 students as a master and PhD. Currently we have around 46 countries students, and out of that 1/3 is PhD students in different programs, different schools. So that's just brief, and you can see that what we do there, as a faculty, as a professor, our job is 30% time to teaching, 70% time to spend on the research. And that's not only me, many of our colleagues do, even as assistant professor or associate, because that's the mission of the institute, to work for the region, to work for the nations. And when you say region means Asia, Pacific, or Asia, and then now beyond that, obviously we have projects and students from the Africa as well. That's we are aiming. And in the region, our objective is to build up the networks, and so I do travel, I do come, and always meet the people to have that purpose. So you can see that this, like a lot of colleagues, when we spend 70% means that's also the research projects as well as supervision of the students. And that in AIT we have master is 2 years mostly. We have 1 year this, but master 2 years is 1 year coursework, 1 year thesis, full-time spending there. And then we have PhD, which is average 3.5 to 4 years. That's the official 3.5 years, but then sometimes it go 4 years, like most of my students graduated in 4 years time. That is good enough, but sometimes they go 7, 8 years. If they feel like that, they enjoy the life in AIT. And AIT is residential campus, so they stay inside the campus as well. So, okay. Anything more if you want to know about this, obviously you can welcome to catch me anywhere in the social media or through email or through WhatsApp number, whatever they are coming. Okay. I'm taking lead on these 2 of the programs, food engineering and bioprocess technology, which has been already 21 years. Actually, I did my master PhD there already, and then I was in New Zealand for 7 years, come back in 2010 as a faculty in AIT, as an assistant professor. And the 3 years back, we started the program. There I take lead on the food innovation, nutrition, and health. And I will give you just brief what we are trying to do there. An objective of this program, the food science is not only to make a food as a product. Food science is more, there's a need of injections of these innovations or ideas to let that food technology industries to grow with more enhanced nutritious food, which can be more beneficial. Like yesterday we saw that what could be the importance, right? So that's our objective. And when we started this program with collaboration with a couple of European universities and some of Southeast Asia universities, it attracts the students even from the medical background. And I have a couple of them, the pharmacy backgrounds, microbiology, and those are already there. So this is the objective of how we can integrate. And so that's the integration of that, where we're not talking directly medical schools or medical like that, but it is the aim of that, those students coming from different background to give the knowledge. You see that there is a medical has some knowledge on the medicines and those, but how you can inject, where we can have more the values of the food as a giving, what we know, what we eat we don't know. We have so many things we are eating, but we don't know what is the impact of that in our body. There's a lot of mystery, a lot of things to be done, and that's the aim of these 2 programs we are doing in AIT. And again, anybody can come there. Now come to my talk. I will not go too much on the immunomodulation because you have more than 1 hour yesterday. you learn and listen from our senior colleague who has been all very profound on that traditional medicines, and he has been doing a lot of work. So I will not go into do details on that. I will go on the diet system, rather the food systems, how we can maximize the value of the food. That will be my almost 1 hour. I will try to get with you. Maybe if indigestible, you can cross me anytime the questions. Why we are talking this? And we know that we have all the time talking food security, rather food insecurity. But for me, more than that, we have nutrition problem, huge problem. One time we are talking obesity, another place we are talking malnutrition. We are telling that we have rich, we have a lot of food, but at the same time we are talking undernutrition. Why it is happening that? That question remains. I've been working for 20 years. We have senior professors here. We still need to find out, and it will be going on and on, right? So this is the question comes for the science, for the technology-oriented professionals, to the educationist, what we are teaching, and more than that comes to young generation, youth generations, to figure out how we can solve these problems and give, how we can. We are talking about SDGs, Sustainable Development Goals. We don't know how much we have success by now when SDG 30 is coming very soon, not very far. And last 10 years, how much we have achieved. Question marks are still there. When we look for this, still there. So this is just like this. So what is happening? We know that one. The first is that we don't know. Actually, sustainable food systems is a big word. We are talking all the time. How much we are reaching. And if you see in my slides, just like the food, what were there? There are the still problem we have of poverty. Why the people are still hunger when we talk. Why the people are still having not, like even you talk in the India, suppose context. Now we have been talking all the obesity things in the US and those, we started the food. Is it the ultra processed food which is making the impact? Why suddenly in India increased the obesity? At the same time, we are having, I mean the South Asia, if you talk similar like Africa, we are having undernutrition, the malnutrition people. Why there is just so much, variations? Where we are lacking? Is it only the poverty things, or is it the what we are doing? I mean, the knowledge is missing there, or we are not caring, or our food systems, food habit is not a proper. So there are a lot of things to be think of, other than the natural disasters, climate change, and all those things. I think we are still far. Somebody was asking yesterday adulteration. That is the far, away that we need to think of. Yes, we have the problem with this adulteration, the safety regulations, those things are there. That is another side of the discussions. So we'll not be talking that, but that is also important to think of how we can come over. But all these things are changing. But in the current scenario, what is happening is the dietary pattern, dietary changes has been very fast changing. The way of the food habit, what we have been eating past, that is changing now. The scenario has been changing. And especially when you talk, the generations have been now adopting very fast what we didn't have habit. And you see that is affecting on a lot of metabolic sort of diseases, what we call there. A lot of syndromes might be coming in the new generations. That is alarming situations as well. More than that, it's not like for us we have, but the aging society is another issue is coming. Like in Japan is number one, having 35% already people are, when I talk aging, 70 plus. In Thailand is 25%. So there is an issue coming like that, how food systems has to bring that can solve, because it costs billions of the dollar or rupees or baht for the cost in the medical cost. So like in Thailand, the government has made a policy that every big enterprises or medium enterprises need to make certain type of food products which is more suitable for the aging people. Okay, and the purpose is that it should be now, when we talk the food products, it should be more digestible, more palatable. The taste should be that they like. Chewing and all those things are there. So that type of things are coming. Another important aspects looking. The same time we faced the COVID-19, and if you look in the COVID-19, majority of the people affected who has been immunocompromised. Yesterday we learned already that one. And most of the people either long time disease, having sickness, or having deficiency of these, especially we talk the proteins, or you know that suddenly the people tell, okay, you have zinc deficiency, start eating the zinc. You need a zinc tablets to eat. So a lot of things came like that way, which gives us knowledge as well, but at the same time. But if we look in the analysis of this, that shows that our food has a lot of missing components, right? We have been eating, right? So, but we don't know what is the missing. The very old saying is saying you eat an apple every day, the doctor, you don't need to go doctors, right? There is some saying. Now in the food safety is different, that we don't know what we are eating when we eat the apple or the full whole, but at the same time, is it that the true? But there are a lot of impacts have been there, which is coming. So our food has to be a very holistic approach to bring there, which can help. Like I mentioned, I will not go too details on now. On the immune systems, I will be talking only food, otherwise, and then give you some of the ideas what we have been trying to do in the lab, how can the processing or the food can be impacted, that more nutritional things, what we have been talking since yesterday as well, we'll be talking. So what we need to inject is that, you know that the ultra processed food, I mean, you know already what we have been consuming. It is not, as a food science, I don't prefer myself to talk any food as a junk food. Nothing is junk food. Food is food, right? We are eating because that's edible, everything. So we should not say junk food, but what we say is that the processed, the ultra processed, when we make the processing is affecting on our health systems. That is affecting on the nutritional quality of the food that we have been ignoring because we want to advance the industries to go like that way. And once we are advancing the industries, now industry look different aspects than quality or health. They first look at how to increase the shelf life of the product because they will have more economic value there. Then comes to the health. And when you look in that angle, then obviously the processing more like preservations or putting like, you know, that when you make, like suppose the one example, very good example is that which is we are affecting now mayonnaise, suppose make there. Now mayonnaise has been made with emulsion, they use a lot of other additive substance which is not good for our health, okay. So there are a lot of that. French fries, very good example. You can see I'm just giving you that where we need to work. Everybody loves French fries. And we know what type of French fries you love. If you don't have crispy, you don't have dark brown, I think 90% people don't love to eat. But you know that WHO has already given now that once more, don't get scared. This is my job to make aware only. WHO is giving the indication or all the regulations is coming. Darker brown, and we know the science behind it already. More darker French fries you have, more crispy you have, you are making more acrylamide. Now all of you know what is acrylamide. So think is now there how to reduce that one. So it has been there and people have been logging, that's a consumer, as a consumer we love it to drink. But how we can minimize? Now that's the job of now science, the young people who are doing the research, who would like to do research, that you can see. And you can see some industries are making there. You have seen the Lay's has produced something even crispy, but not dark brown. So there are products that will come because that's the demand. But again, the one packet of Lay's is 10 times higher than the normal chips or French fries or chips you buy there. So we need to think. So what there is now we need to think ideas to generate everywhere. We have the process, we have the food materials, we have raw materials. Now you need to think of how you can maximize, so which has the quality. When I talk quality, especially talk about the nutrients, the nutritional value of that food, that intact, remain there, right? Obviously we need to have the process we need to make. Some products are making very easy to make as well, but still we are destroying by heating our cooking systems, right? That's like when I teach one my class, and I told one, just very first class I talk by students, tell that, do you know why the Japanese life expectancy is 100 years? Okay, so there are some research has been done. The people are saying because they eat the fish. So one of my Bangladeshi student was sitting behind, and he very told, so we are also eating the fish every day, every meal, but our life expectancy is only 55 years, right? I'm talking 5, 6 years, 7 years back. Now you know the answer. very well why it is like that. Yes, Japanese eat fish, and we talk yesterday omega-3 as well, right? So fish do have that one, you know very well, getting there. But the way is they eat the raw even, right? Eat the fish raw, so you get everything, all the proteins, everything. What we do, the cooking, is that we deep fry, right? And then we put all the spices there, which is we don't know what is happening with the omega-3 or fish oil, and what is happening with the proteins, the poor there, right? That become poor. So we don't know what we are eating. We eat for the taste purpose, while the Japan eat for, but that becomes their taste. I also try one time eating the raw when I was sitting in Japan with professors. So when you are sitting there, eat raw, but that was the first time for me. So I eat, I could not ignore, I eat, but just along with that, I took 4 or 5 glasses of beer together. That was my survival. So that happens, but we need to change. The purpose of saying that we need to change. We need to change the processings. That's the industry has to think. And then we need to change as a consumer as well, the food, how we can cook, or cooking habits or eating habits. That need to be there. Not only thinking about the supplements, not only thinking about the medicines, okay? Thinking about the food, how we can generate there. And that's the way, and there is a need of those injections of what is surrounding us. Now I will take you some surrounding we have, how we can improve that one, the things to do. That's the bio-innovation I put there. I put this slide just for study we talk as well. We have the phytochemicals. Now phytochemicals come from where? Plant-based foods. All these plants are there, whether you say in the traditional medicine or we put as a directly in the food systems. We are eating every day. We have tea, we have coffee, we have milk. We have all the materials there. We eat like that, okay? So there are different ways of the process. And I can just tell you that what is the needed now, simple thinking. Every student, alternate student comes and tell that, sir, you have too much exam stress, too much assignment stress, all the time talking. So I suggest my student eat banana every morning, eat yogurt, which gives you probiotic, right? And your stress will go away. I don't know whether you try or not, it will work. The banana works. A banana has a direct serotonin, and you know the serotonin and dopamine is the happy hormones that affects. So you can try. If it works, you can send me message. If not works, you can scold me and keep quiet for a while, okay? But just like a psychology, this is a psychology. But thus, what is the purpose is saying that those contain certain amount of active ingredients which is beneficial to us. Now, you know that this melatonin gives the sleep. If the deficiency of that hormone, we get the sleep disorders and those. And one of the company in Thailand is not a very big enterprise, medium enterprise. They have introduced sleeping milk. So I work them as some helping as well. Now I asked, how did you do that one? That's a simple thing. So biochemistry, if some of you students know, you know that how the melatonin is synthesized in our body. So what they did is we did the manipulation in the feed of the cattle. And that makes some biochemical changes, and that makes milk with certain amount of melatonin coming in the milk itself. Now, that was the purpose of making sleeping milk, because he was thinking that the newborn, the new mothers, and those having not, so they can get the good sleep. But he is getting more now with the aging society people, more markets. And then I suggest him to make tablet, because it is jet lag problem as well can be solved by this. So he's working on that. You can get the tablets of the milk. So the purpose of saying that there is a simple, it's not a big thing. We need to think. Our mind has to come out from what we have been doing. How the industry can enhance the process to get benefit. Like yesterday, we talk about omega-3. I will come back there in the processing, but I can tell you here as well. Now, if you go in Thailand, I don't think we have here. In Thailand, you can find omega-3 egg. Now, we know very well the chicken does not have omega-3, only the coming from the fish oil. Or microalgae, which give ALA, and then you get translated into the omega-3, that is the EPA, DHA. Now, where it comes from? So what has been done is that feed of those chicken has been changed and putting more ingredients which can convert. Now, chicken does not have the enzyme which can make ALA to that, the EPA, DHA, same like human being. So what they do is they make direct the fish oil to increase, means coming from the intestine or from the fish as a adding more additive in the ingredient, and that is, it could be tinge amount, but you know that the price of that egg is almost 5 watt, means 5 times, not 5 times, 5 watt more of the per egg than that, because the people love it. Now people think that omega-3 having egg will all the time we are looking for the fish is there. So that gives. So those type of things are coming now more, and industry who gives the science needs behind that to think of. So everything should be evidence-based, and the science they're coming. The probiotics and prebiotics or symbiotics, now everybody, I always talk when I give, the probiotics for me is, we talk all the time, whatever Ramayana Mahabharata study we talk as well. You know, the probiotics should be, but the Yakult was introduced by Japan. So we miss our train again. We could not reach our, we lack. The Yakult become within 2 years, the person who developed this Yakult become millionaire within a year time, but we have been eating yogurt generation, not generation, even ages and ages, right? And then we miss. Now we know the value of that probiotic, that's 1984, 85, it came there. Now a lot of people have been working, and yesterday there was a nice talk already, second talk that you talked, that there is a products, whether milk-based, plant-based, or as a wine or whatever coming there. So you know already their probiotics have the benefits, a lot of benefits there, but how we can incorporate in the food systems? Either one we have. I told that eat every morning yogurt. Now if our habit of eating is, again, there are some problems, right? What we have been eating is that eat a lot of meal and then we eat yogurt. Okay, now if you talk about this, if you want to have effect from the probiotic cells does not have effect in the stomach, probiotic cells does not have effect in the small intestine. Probiotic needs to go into the large intestine, because that's our bioreactor, human bioreactor. Now, if you need there, if you have a lot of meal already, which is our habit is to eat bulk, now then eating yogurt, be sure that you are not reaching even 20% of bacteria what we are consuming reaching to the gut colon, the large intestine. So we are missing again there, this effect. But if you eat in the empty stomach, the transient time of a stomach and in the small intestine is much, much lower, which is making rather than 20%, your 80% bacteria. Why is your stomach is not favorable? Because the stomach pH is, you know, everyone here in this room, pH is very, very low, which even the lactobacillus or bifidobacteria or any type of probiotics, they cannot survive for a longer period. So if short transition time, it can have, longer, it will not have. So that we need to think of how we can maximize the values. We are eating, but we are not eating properly. We have the substance, we don't know how to utilize it. So these all things are now changing. So changing in the science as well, we need to think more innovative. Changing the industry as well, how industry can maximize making the products like that way. At the same time, knowledge management is necessary for the consumer as well, how we think there, okay? So there are a lot of, I'm not going to details, but I think the next talk will be also a little bit on fermentation, fermented products as well. So we'll be learning more there, what are the benefits, how is helping there as well. And now we also talk about gut-brain axis. We talk about the leaky gut, where, you know, the intestine having or epithelial layer. You know, one of the factor now why the probiotics is getting much more market and values, because there are a lot of products are coming, so a lot of the diseases are coming, especially for the gut systems, is affecting a lot in our, so there is a role of these probiotics. And now there's a lot of proven theory. If you love novel to read, some of you, then recently one book has been published saying that 20% human cells. Means we are, 10%. So we are 10%. 90% of the surrounding or in our body is mostly occupied by the bacterial cells. Means the probiotic good bacteria, some are obviously bad bacteria sitting there. So you can read there and you can learn more as well. Now this is we have every day. We have been eating a long time, not only here. South Asia, Southeast Asia, East Asia, China, those are very much popular of these traditional fermented foods, right? We have been consuming there. And when it came, the theoretically or you can hypothetically, came as more a preservative purpose, you know. So it was not for the nutritional point of view when it was started long time ago, right? And then that was the purpose of making pickles and all those things. But now we can see that a lot of values have been there. When you go and analyze, a lot of anti-nutrition factors have been diminished, means reduced or almost gone from there. Or it increases more values of, you have the good proteins, it converts into bioactive peptides or the amino acids, which are giving high values there. So these are the values of this, the fermented products, which we have been somehow not commercialized or not have been maximized to value to the industries and beyond. But there are some, again, like kimchi, everywhere in the corner of the world, everywhere is there. And they have been promoting like that. They are not telling that kimchi is good for you, but they are saying kimchi is good for your health. So we need to promote like that way, just to making a lot of, so not only shelf life to increase, but increase, that should be our, from the science evidence to show that the industry can sell their products in that all as well. Okay, like again, I told that I will not go too detail on this, but there are a lot of ways that from the vegetables with fermented, if you can show there, if you work, I think some of you are working already, a lot of papers are coming from the region as well now showing that, but still we are missing to go for the industrial purpose, how to develop. I tell you a couple of examples only. I mean, there are some products in the markets other than what we talk about the dairy-based or what we talk some plant-based. There are meat-based products. In Thailand, suppose this is very, very popular products from the traditional fermented product, which has been, they are commercialized in very nicely. From the pork it started, but from also coming from the chicken and those as well. More. So a lot of products are coming to the market and we need to bring our products as well. That's I emphasize here as well. Tell you one example, I was working with my students thinking about that, some hypothetical. Is it possible to increase the folic acid in the product what we are consuming every day? And why it came in my mind, it was, if I think yesterday I was talking with the colleague, the churpi, which is Nepal, has very much popular from yak, also in the mountainous region coming. And you know, especially the young girls, ladies, they always chew, put in the mouth and all the day chewing, whether you are working office, working lady or in home. And idea was mine, the folic acid is coming, the tablet when the ladies go for the conceive or thinking about having baby, the folic acid doctor prescribed. So I was thinking if you can put some extra amount in those churpi or that type of products, which can give, because churpi, why? You can chew for a longer. Obviously, we will not put in the betel nut. That's not good. So thinking about the churpi was that the idea. So making there, we were successful to increase the concentrations. But unfortunately, the folic acid being a water hydrophilic, means more water soluble, it was going to the whey. So whey can drink, get more. But then there was a company came to me from the Thailand is more, not the dairy milk, but the soya milk is more popular. And you know why? Because they have been this lactose intolerance problem. So majority of the consumer is the soya milk. So is it possible to make in the plant-based? And we are successful to make in the soya milk. So one of the company adopted that, which we've increased by 150% of this, because soya milk does not contain folic acid at all. So increase their value getting by, so it's like simply like a drinking yogurt, but based of the soya milk. So just showing some examples of that is possible. Now another classical example what is there, you know, we have a lot of products here. Now this mashura is coming from Nepal as well. And because I give example, when some of the company adopted this one. Now we have been traditionally making, like, you know, we make many traditional foods as well. So this is one of the product we are making already there. People eating every day. It's coming from actually black soybean and then adding some other starch materials, which is obviously the fermented products as well. So this, I'm not sure what is called in that, must be having this east side as well, but this is popular name come. And so this was here, the objective of mine is there to show the evidence that you can optimize, you don't need to go for 7 or 8 or 10 days of the fermentation, you can reduce the fermentation time, and which can give you more value. And especially looking for the amino acids or essential amino acids increase there, or some vitamins, we look for that one. First thing what we did is we optimize the conditions, so you don't need to go for 10 days of fermentation living like that, and then you get the start making, or even 7 days. We reduce to overnight 48 hours maximum, 24 to 48 hours, inoculate the bacteria which you get from there itself, and the combination of the co-cultures, and it can increase a lot of some of this I saw there, which is increased by almost 5 to 10 times in value of amino acids, which is high for me to show the industry the evidence that there is a way that you can increase and you can show the value to the consumers. Okay, this is the needed as well. Okay, so quickly, I will not go too detail on the graphs and that, considering the time as well. And I'll just show you that what is the recent. Why we are eating a lot of yogurt, but how this study we are talking as well, how this is giving the value. So probiotic based, what we are looking here that making the process from the goat milk, suppose now, which is the potential coming for the future as well, milk, not only the cow milk, and you know the goat milk has coming a lot of high values, some perspectives, not all, but some perspectives is giving. So we are looking that whether the bioactive peptides, some of colleagues here also work on the bioactive peptides, can be increased by using particular bacteria or combination of bacteria with some physical, you know, that giving like ultrasonication we have used. This has been published in Journal of Dairy Science, and increase. So we look all the values, and what we look for, I'll not go, like I mentioned, there is an increase of these percentages of peptides or amino acids as well there. But what is the more important is that looking the bioactive properties. So look for antioxidant activity with the different type of bacteria. Obviously they are using and give that how increase there. Okay, so if anybody is interested on that, you can look in the papers or you can discuss with me later as well, while here or later. You can see that we also look for the ACE inhibition and those activity, and which gives the increased concentrations, just normal milk compared to the, it is make fermented and those. Okay, so I'll skip some of the slides to coming there, but this is obviously anybody interested, you can come. This is a very recent, one of my PhD just graduated. We published 4 papers from here, and that's interesting for me to make you know, colostrum everybody knows in this room again. Now, colostrum is the first milk of cow or milking from coming there, which is necessary for the neonatal. But when we look for the, obviously this is industry-based project. Industry was very interested to look, to develop the colostrum has antibodies, high antibodies, which can be beneficial. But how can you make solubilize and more productable? So here you use the nanotechnology to enhance that one. Okay, I will not go to details on that. But what I will tell you that the objective of this project was how this colostrum can make a powder which is more soluble in water and also increase the shelf life. So the idea came, if you make the engineered nanoparticles, means protein has the tendency to self-assemble, and through self-assemble, you can change with the pH, and that can effective nanoparticles are produced, which can increase the digestibility, which can increase solubility, digestibility, and bioaccessibility. So when you look, surprising of this was first, the colostrum, these antibodies have been reduced within the 3rd days. So people say that you eat for 7 days, you have effect. But this is all proven now, and some of the research also done in earlier days from the cow milk and those, and we found that what is in day 1 or day 2, slightly reduced, it goes much more lower. So the objective of get this one now, you know, currently the colostrum, this powder, just colostrum powder, if in Australia has produced as a commercial, 1 kilogram costs around $200. Now that was the Thai, obviously objective was the one of the industry to make this one, and it should be more soluble, more marketable purpose of that. So we have success somehow. This hopefully that the company will soon produce this product as well. We develop these nanoparticles by self-assemble. I mean, its thinking is complicated, but when you start making, it takes time, but we have succeeded to make that to reduce. So a lot of parameters were done there to how to make there, playing with the temperature, playing with some of the ionic, like the calcium, some arginine where they are added. We have success. So just only showing the success of that, adding some of those particles, successful particles. Obviously PhD, you know that some of you doing PhD is not a one-day job. It takes 4 years at least to get those particles. But the good thing is that after doing all these, we also look the in vitro digestibility, bioaccessibility, and the same time we also look the animal studies. which shows that the IgG and IgA is the higher concentration in the serum than compared to the just giving the colostrum to the rats. So that is the purpose, that's the bottom line I show you here. I did not remove the slide, but just to going quickly off this one. So this is this type of projects. Now what I mentioned here is that there are the technologies here, there are the thoughts. We don't go in the traditional way of thinking. Little bit injection of science, the innovation, the ideas, which can make your product modified, can also increase the shelf life and also increase the value of those products, right? That should be possible to commercialize as well. Okay, now another cycle I take here quickly on this underutilized, which we are very rich, but it's no more now underutilized. I think I have to remove that word now because it becomes a superfood. You know that what is the millet? I'm talking about millet. Now millet has been 5-6 years back. FAO gives him 2016 when first my PhD student from India I give her this assignment. That time the FAO has put millet as a underutilized. If you see the go and look there that time. But within 2-3 years, millet becomes superfood. Everybody wants that to eat. That was surprise. Last September, I was in conference in NIFTM organized near to Delhi, that Kundali. Almost 400 people all the time, all were talking about millet as a superfood. My question was there, why we have not been eating since last 100 years? Why suddenly become superfood? And that's the question that still remain. But we need to think. There are a lot of values there, obviously. And you see that. And the new generation of food is coming as a plant-based, looking for alternative proteins especially. And you know that there is edible insect has been started eating, even in Thailand. Some of the edible insect has been already commercialized. Globally it is coming. We are getting the cultured meat as well. If you read somewhere, if someone interested on proteins, you can see there. And obviously plant is a good source. But all the time what we have been teaching and learning that plant is not a whole food because plant is lacking certain essential amino acids. Without doing too much science, we start saying like that because the animal products were more in the market, and we know that if you eat 1 egg or 2 eggs, it gives you enough essential amino acids compared to if you eat plant. So that was the thought coming, but we need to think, there are a lot of plants we have around here which has the amino acids, not full amount how much we need for daily, but if you mix 2, the possible is there, you get there. And that's I put here. So we have been working on this now, at least 4 of my PhD students are working on this, how to increase the value of that. Why millet we have not been eating? Like I see from my side, my childhood, when my mother was giving to working people to eat the millet, but not for me, there could be logic why not giving. Working people, obviously it gives a lot of energy, a lot of fibers there. This gives the long-term, satiety effect as well. But at the same time, for kids, own kids, not giving, because they do contain some amount of, the ingredients which is not good for us, what is called anti-nutrients. So we need to think how to process. So what we are doing there is now mixing. There are the ways of it can reduce anti-nutrients and increase the value of the amino acids or other things. So that's again we are talking, see that these are the major problems what we observe in those millets are all underutilized, you can say legumes or what we say dal and those things that we have. But we need to increase. So there is a chances that increase by, one is the fermentation or increase by germination. Those are like not the conventional methods, it is a change. Now fermentation is a conventional, but not as a conventional to put. And we have already proven there that you do the fermentation, combination of fermentation and germination is more effective, give there as well. You need to increase more essential amino acids. So these are there in the very dormant stage, which can be increased by injecting certain type of processing conditions, which can help. So that is also there, which can be used, and we increase their values as well. Okay. Sorry if I skip the slides, if anybody has, because it's too much on the science-based research. But if anybody interested, you can read the papers which we have published already, or can communicate with me later as well. I'll just show you example what is now, that there is a concept coming, meat analog or meat-based, plant-based products. I'm not sure, we don't have here, but if you go in Thailand, Japan or those countries, they say that you can have the plant-based burger, means patties with the plant-based meat burger. And there is even product is called plant-based chicken burger. Chicken plant is plant, but what they are doing is they are making the analogs there. So that's analogs. There is a use of new technologies. Those new technologies can help them to produce there as well. Okay, so there shows that we have these amino acids and those can be increased, right, the value of those things as well. Okay. So this just show that combination of those, you can produce different type of products and those. But I show you this, there is a new technology called 3D printing. Some of you might be working in the food industries or, I mean the food lab. The 3D printing is similar like the printing methods layer by layer to make. So you can have suppose polysaccharides, you can have proteins. So this is very personalized to as well. And that is helping to develop different type of meat analogs. Okay, I think it's working. Okay, just skip that one, it's fine. No video. Okay, so this is now on a new concept coming from the plant to make like meat. It's a substitute to bringing there. And this technology, so we have some of the labs, people are working there as well, sorry. I'll omit, I'll just stop here. Okay, so this is from the plant-based. I'll just highlight here the new technology is that this 3D printing can help, rather 4D printing. You can add the antioxidant or you can add some phenolic compounds there as well, which can make more beneficial layer by layer, and this is developed from there, the different type. We look for the texture, we look for the products, look similarly, but the taste cannot be. So improve the taste also, you can add some of the, suppose, the fatty acid, essential fatty acids there, which can be. But the more challenging is there, how do you make the mixtures that can be more extrusion or can be made there as well, okay? So this is the value added for these type of products. So I just give you some examples with the time constraint. I think I should not take more time. There are a lot more in my slides, but I'll be happy to anytime discuss for the different type of how we can make our emulsion systems or the encapsulation systems, which will be more beneficial to incorporate, which can increase the shelf life, which can increase the processing parameters, which can increase the digestibility as well and the viability as well. So with this note, thank you very much. And if you have anything, welcome to say.
Thank you very much, Professor Anal, for your fascinating and informative lecture. Now, his deliberation is now open for discussion. Unfortunately, I cannot allow too much time for discussion. And I hope, please be seated.
It's okay.
I hope you don't mind to have a silly question from me at the outset. My question is, nowadays, many young mothers give their newborn babies, something called formula feed, which are not supposed to contain any antibody. So what is your opinion? Such formula feed may be detrimental for the development of immunity of the kids or not?
I think for the new baby, the best is the mom's milk. That is the knowledge already propagating and the best. So if you look in the milk, obviously the mother's milk coming, the antibodies there, which is good enough. What is happening is that, like, I did not put here in the goat, why goat milk is coming more for the especially young and neonatal babies as well, because from some of the cow's milk has been found there are allergic compounds. So increase the immunity if you give, that is also giving sensitized to those children.
No, but normal milk contains natural antibodies.
Yeah, natural antibodies.
And do these artificial feed, means like formula feed, contain antibodies or not?
Yeah, artificial is, if you're talking synthetic.
See, I don't know whether it is synthetic.
Yeah, synthetic is never good. And that's why I was telling here. If you can increase the value in the food itself, which is biological things coming, that will give the value.
Is there any way to add antibodies to these formula feed?
Yeah, that's we give example of the cholesterol. That is the purpose of that company is looking for that. Can combination of alone cholesterol milk will be there, which has high antibodies, or mixing with another type of food materials, which can be fed to the aging, but not only for the young, I mean the
Kids.
baby born, but it can be for the aging society as well. That's the because there we need to increase the more antibodies as well. That's the purpose, I think, that type of, and that was when we were discussing of this project actually. The industry came with that because they see the market. Because like Australia, one of the companies selling $200 per, so he told that, is it possible I can make 2,000 baht, which is almost 4 times cheaper than Australia, so he can take bigger market. So for his was the economic, but for us was the more looking the science behind it, how you can increase the value of that, what is there. That's why we got all the cholesterol from the cows, and that's obviously from the Thailand, looking for there. And then we all analyze, which was surprise for that industry itself, because he was thinking the 5th day of cholesterol has the good value of antibodies, which is not correct. So that's why the now industries are making more synthetic, and synthetic proteins have been for a while. And that's why these alternative protein sources which is coming, as a science saying, rather edible insect is better than having synthetic in our food, right? And many of the companies, many of the countries already adopting edible insects. Like if you know in Thailand is very common now, there are 4,000 farms have been established in the last 5 years from the cricket. If you know the cricket is, okay, so that's yes. So that type of foods are coming now in the future, so why we need to go and adopt? It will be a little bit difficult for us for digest this generation, but coming generation will be knowing, even what is that, cricket or grasshopper, everything is edible, so we'll be eating, you know. That time those concepts will gone, we will not feel like, oh, it is not good. But for the point of, nutritional point of value, that is more. Same like, you know, that when we, just for adding of this, when we came, the food, you know, when it was coming, the supplements start coming into the market. When we start making a lot of ultra-processed food, and the company was knowing that when we make ultra-processed food, sorry if some company people are sitting here, but ultra-processed food you are making, you are deteriorating or you are denaturing many of the good compounds there. And that's why we need to inject these supplements, and that supplements came there. Rather than thinking, so now generally, now need to think more how we can increase rather, even the processing needed, we can't avoid the processing. So you need to, like you know, lot of non-thermal processings have come into food systems. We know that. And there, how can you inject that? The biological macromolecules or biological molecules should be increased. If not there are some phyto things there, how you can incorporate. There are some good bacteria, good microorganisms are there, how we can incorporate there. That need to be more done, I think.
Thank you, sir. I shall be happy if some of the students could ask some question.
Hi, sir.
Any question from any student? There is someone. Please hand over the microphone.
So I have just a general query. It's a nice presentation, sir. At first, I should acknowledge that. So the company people, whatever they are producing or preparing, they're selling that. So two aspects is there. So if anyone want to enrich that, how to approach them? First thing means, or if you are giving, if you can give some suggestions on it.
To the company or?
Yeah, to the company. Suppose I want to modify some food items with the purposefully, suppose any therapeutic food it can be or something. So how to convince them? One suggestion I need. Another thing that, sir, this kind of modified food, how much is the cost effective? It can be reachable to the poor people or something else. Means if you can tell something on it.
Yeah. Thank you. I think the most difficult question, how to convince industry to come to the science, is very difficult. We are not in US. You know, that's, even you bring like a lot of good science, is very, industry wants quick answer, and they want, like you tell the same second question, should be more cheaper that they can access to the market, it can be sellable and those. But I think our company has to be, know that, like yesterday we are also talking, there are a lot of products which is, a lot of technology we are adopting from somewhere, which has been very fit for them, not for us, right? And that's why we are missing those technology to integrate simple things, what we have surrounding us, we could not incorporate and we could not give the value. So I think we need to make such type of conference workshop where we should bring the industry as well. That could be one approach to make, that's called the knowledge management. So that has to be there. and then giving the value, science, evidence-based, and then also giving the feasibility that you are going to have tomorrow. You can reach to the people, you have the cost-effective, or you have more market. That should be from the science side also. And the third thing is the policy. So there, I always say that there is a policy, science, and industry. Three marriage is very much necessary to do any technology to be enhanced. And if you look in the history of all those developed countries, I mean, so US or Europe or those countries, now the company comes to the science, means the researchers, not researchers need to go, which is opposite. Not only here, even I have in Thailand is the same way, that sometimes we need, and then if you present like this, some industry comes. Like I did not present encapsulation. Like I was surprised when I was doing encapsulation in Massey University with the probiotic cells. The Pepsi Cola called us that we want to, so my director told that, okay, they are in, and I was surprised, why Pepsi asked for probiotic cells? So the Pepsi has now sister organization, they are making beverages, they are already introducing, actually, we did patent, now it is already, so we make that probiotic cells can survive up to 95 degrees centigrade. So that's the way sometimes to work, and we need to make industry to awake that you have the value. But we need to give the very, not very high technologies, the low cost technologies, and very much robust as well. I think that's could be there.
Sir, I would like to ask you a question. That in your presentation you said that soybean and other legumes contains anti-nutrients. So my question is, what is the right way to eat that so that the effect on these anti-nutrients can be minimized?
Thank you. How directly to eat? There are certain, soybean has not too much anti-nutrients. So if you're cooking, heating up, those can kill those anti-nutrients by processing and those. But then the other way is that when there are a lot of value-added products have been developed from soybean. But when I was talking millet, suppose, it does contain quite high amount of oxalate, phytate, phytic acids, such type of some enzymes which can be detrimental effect on us. And also in some of the legumes, not all, some of the legumes. So there we need to have certain processings. Like I give example what we are doing in our lab, looking for the germination process, and then make the flour from there. Or then you make some, value you can cook and then you eat. Not directly eating that one, that can give. Or combination, like you make the fermentation for a while, and then some certain things have been reduced that we have found also, and then you make the flour, making the product from there. That's the way. So you cannot consume directly. There are certain things, obviously, when you consume, like, you eat many products. Like people say that, okay, this leaf has a lot of value. We started putting in the hot water and start drinking as a tea, which is not good, actually. You are consuming a lot of anti-nutrients as well. So you have to be careful. So as the science, you need to look all those things which can give value.
Yes, sir. That means that boiling.
Boiling is not only the way.
Yes, sir. Thank you, sir.
Thank you very much. Thank you, everyone. Thank you.
A big round of applause, please. For some unavoidable reasons, there have been certain changes in the schedule. I do apologize to Professor Madhumita Barua. She will be speaking third, and Dr. Dept Bhattacharya will be talking now. Dr. Dept Bhattacharya, please come to the stage. And it is now turn for our teachers to formally felicitate Dr. Bhattacharya on the stage. Abhishek. Now, I introduce Dr. Bhattacharya to you all. Dr. Dept Bhattacharya is Scientist E, cum Deputy Director of ICMR Regional Medical Center at Bhubaneswar of Odisha. The arena of his research activities include medical microbiology, virology, molecular epidemiology, infectious diseases, zoonotic diseases, antibiotic resistance, and public health. Some of the landmarks of his research career include participation in management of avian influenza outbreaks in Puri and Bhubaneswar, development of Odisha-based coronavirus antigen detection kit, development of human anthrax diagnosis facility at ICMR Regional Medical Center in Bhubaneswar. Dr. Bhattacharya happens to be the member of a number of public health-related statutory bodies of Government of Odisha, such as Zoonotic Coordination Committee, State Rapid Response Team for Outbreak Investigation, Technical Evaluation and Managerial Committee of Odisha State Medical Corporation, and so on. Dr. Bhattacharya presented his papers in conference of the International Society of Infectious Disease in Kuala Lumpur, Malaysia, and also in the University of Edinburgh, UK, in addition to acting as resource person in several symposia and conferences. Dr. Bhattacharya has so far supervised 10 research projects, most of which were sanctioned by ICMR Government of India. About a dozen of PhD and MD scholars earned their respective degrees under the supervision of Dr. Bhattacharya. Dr. Bhattacharya has nearly 100 research publications to his credit. He has authored 4 book chapters. Dr. Bhattacharya is an editorial panel member of different peer-reviewed journals like PLOS ONE, Frontiers in Public Health, Frontiers in Antibiotics, Frontiers in Medicine. He is also a reviewer of several scientific journals like British Medical Journal Open, Journal of Infection in Developing Countries, Journal of Clinical Epidemiology, African Journal of Microbiology, etc. Besides, Dr. Bhattacharya is the owner of different prestigious awards in recognition of his contribution to research and academics. Noteworthy among these awards are Bill and Melinda Gates Foundation Professional Development Award from International Society of Infectious Disease and ICMR Centenary Gold Medal for his outstanding research contributions in the field of shigellosis in Andaman and Nicobar Islands. Today, Dr. Bhattacharya will be talking on foodborne diseases and food safety using a holistic approach of One Health. I, on behalf of all members of this college, cordially welcome Dr. Bhattacharya for starting his deliberations. Welcome.
Very good morning to all of you. Basically, I feel I'm an odd man out because I am totally away from food and nutrition. I'm basically a public health microbiologist. And so when the organizing committee invited me, I thought, how will I respond? Should I go ahead or not? And then I thought, okay, let us link food hazard, foodborne diseases, and One Health, because since the recent public health emergencies caused by Nipah and COVID-19, One Health has been recognized as one of the biggest field which needs utmost importance to combat and manage various public health emergencies in our recent future. So, my topic is foodborne diseases and food safety using a holistic approach of One Health. So, let us make it a very interactive session. Means you can stop me anytime if you want, and I will try to answer your queries. So, any one of you do have an idea of One Health? What is One Health? Okay. So, my presentation will cover the introduction, food safety and SDG 2030, food hazards and its type, foodborne illnesses, common foodborne pathogens, key principles of food hygiene, One Health, and food system. So, as you all know, food safety or food hygiene, it refers to the routines in the preparation, handling and storage of food meant to prevent the various foodborne illnesses and injuries which may happen if we ingest a contaminated food. It involves the various scientific method or disciplines that describes how to handle, prepare, store the food in order to avoid the food contamination and thereby causing foodborne illnesses. So, food that we eat at home or outside give us various nutrients for normal functioning of the body. Have you ever thought that food that we eat, how does it process from the farm or the field to our spoon or plate? So, from the farm to factory to spoon, food products may encounter n number of opportunities to get contaminated and thereby cause foodborne illnesses. All the participants sitting here, I am quite sure at some point of the time in their lifespan, they might have got infected to some kind of foodborne illnesses and they have got sickened. So, a foodborne illnesses is a disease that is carried or transmitted by contaminated food. So, for a better future, WHO has set up some 17 sustainable development goals so that we can live a very good life in our near future. So, the food safety is fundamental to Sustainable Development Goal 1, that is no poverty, 2, that is zero hunger, 3, good health and well-being, 6, that is clean water and sanitation, 8, that is decent work at economic growth, 12 and 17. So, if food is compromised, all these 8 goals are compromised. The Food Safety and Standard Act 2006 received the assent of President on 23rd August 2006 and is published for general information. Food Safety and Standard Act 2006, number 34 of 2006. It is an act to consolidate the laws relating to food and to establish the Food Safety and Standards Authority of India for laying down science-based standard for articles of food and to regulate their manufacture, storage, distribution, sale and import to ensure availability of safe and wholesome food for human consumption and for matters connected therewith or incidental thereto. Now, how does food hazard happens? Food hazard happens through carelessness in purchasing, receiving, storage, preparing, cooking and package of raw cooked products and the various services involved in this transport of food to the plate. Every fruit producer or food handler needs to be aware or sensitized of the fact that they are handling a biological product which has immense opportunity to get contaminated at some point of time and may get degrade or spoil. How do we define food hazard? Food hazard is defined as a biological, chemical or physical agent in or condition of food with potential to cause an adverse health event. Food safety hazards are generally of 3 types: biological, chemical and physical. Chemical hazards. We use various kind of, you might have seen that when we bring the eggs from the poultry farm or from the shop to our house, we see various kind of coating on the eggs. So those are veterinary residues. Pesticide residues. Pesticides are used immensely in the to increase the production of food. Non-permissible food additives. Excess of permissible food additives and cleaning chemicals and adulterants. These are some examples of chemical hazard. Physical hazard, again, we see a number of seeds, stones, threads, insects, hair in the food. So those includes physical hazard. And the most important is the biological hazard. So biological hazards are the microorganisms which themselves or their toxin cause illness when transmitted from the contaminated food to the humans through the food chain. There are various microorganisms which are responsible for food these biological hazards, which include bacteria, viruses, molds, which are naturally and some of them produces toxins. Some can grow on food causing spoilage, and others constitute a hazard to human through illness. Biological hazards are everywhere. We cannot restrict them. They're like soil, water, plants, utensils that we use to handle food, our GI tract, and food handlers, animal feeds, animal hides, air and dust, and everywhere. So what foods are mostly like to be contaminated? We all know this raw meat and poultry that we bring from the shop to our house, if they are kept for a long time without washing and freezing, they get contaminated by various bacteria. Raw eggs, if consumed without cleaning, or even if they are contaminated eggs which are used in the cooking of various cake, brownies, they causes illness. And unpasteurized milk, raw shellfish, unwashed raw fruits and vegetables, unpasteurized fruit juices. These are all complex and multiple operations in food system increase the chances of contamination. By the time food reaches us from the poultry, from the farm, or from the field to our houses, they get n number of opportunities to get contaminated if they are not handled properly. Multiple food handling from food growers to processor to supplier to finally us multiplies the chance of the food getting contaminated. We increase the food chain, from the number of handlers we increase, the chances of getting contaminated of the food also increases. So it is directly proportional. At the source, food grower, food processor, food packaging, through poor control or mishandling of the food. Most if not all food products go through additional step of warehousing, because when the potatoes, onions, when they are coming from the field to the warehouse, to the market, they are stored in various warehouses or cold rooms, and if the condition of that warehouse or cold rooms the temperature are not maintained properly, there are chances of getting contaminated. Finally, the food reaches the final food processing facility at our homes, and it is here that we need to protect it from the point of receiving through storage, so that to preparation for its intended use and up to consumption by us. Cross-contamination. Cross-contamination happens when a contaminated food contaminates a fresh food, because when we use, if we if we are using to cut some contaminated food and then again without washing it, we are using it in a fresh fruit or vegetable, the chances of transferring of the bacteria or microorganism from that raw fruits or vegetables to the fresh non-contaminated fruit increases. This is called cross-contamination. What is foodborne illnesses? The foodborne illnesses are the disease commonly transmitted through ingestion of contaminated food. It comprises a broad group of illnesses and may be caused by microbial pathogens, parasites, chemical contaminants, and biotoxins. Globally, it is estimated that 600 billion people fall ill after eating contaminated food, and 4.2 lakh die annually, resulting in 33 billion disability adjusted life years loss or daily loss. Every year, India witnesses an estimated 100 million foodborne illnesses and 1.2 lakh foodborne illness related deaths, and 8 million Delhi's loss. Foodborne illnesses, outbreaks, and acute diarrheal disease accounted for nearly 40% of all the reported outbreaks under India's IDSP, Integrated Disease Surveillance Program, during 2011 and 17. Now, modes of foodborne illnesses. There are basically two modes of foodborne illnesses. One is when we ingest a food which is contaminated with some bacterial pathogen, or when the bacteria enters the body, they produce some kind of toxin which results in the infection or illnesses in our body. General loads of microorganisms, it causes spoilage, it changes the color, odor, flavor, appearance or texture of the food. It grow to high levels and break the food components. Common cells are generally non-pathogenic or non-harmful organisms. So, but when they increase the threshold in the food, they become a kind of contamination and causes the illness. The different products have different spoilage flora. Now, a bacteria has a growth curve. You all might be knowing that. It is a lag phase, log phase or exponential phase, stationary phase and death phase. So, during the lifespan of of bacterial growth, there are several factors which promote the growth of the bacteria. That it requires water, it requires food or nutrients for its growth, it requires a correct temperature for its growth, it requires a sufficient time or doubling time, and if it is an aerobic bacteria, it requires oxygen for growth. If all these are present, bacteria can multiply or divide into two, that is called doubling time, in 20 to 30 minutes. A single cell of E. coli double itself in every 20 minutes. You imagine, because a single cell it is becoming 2 in 20 minutes. So the longer period you keep the contaminated food outside, it will increase in number, and thereby if it enters your body, it will cause a havoc. So this is you can see it starts from 1 million, increase in the time, you see that it becomes around 32 million. This is estimated for a E. coli. So if a 32 million organism enters your body, you imagine how it will going to create havoc in the body. So some of the common foodborne pathogens which are responsible for the foodborne illnesses, which includes bacterial are the E. coli, Salmonella, Staph aureus, Listeria, Campylobacter, Shigella, and Clostridium botulinum or Purfringes. In viruses, it includes norovirus, rota, and hepatitis A. Among parasites, there are Cryptosporidium, Giardia, and Cyclospora. So, if the E. coli, the source is raw, undercooked meat and unpasteurized milk, symptoms include nausea, vomiting, bloody diarrhea, dysentery, abdominal cramp, usually lasting for 5 to 10 days if it is untreated. If it is treated, sorry, and cause death in children and elderly also. The prevention is thoroughly cooked meat, avoid unpasteurized milk, wash hands carefully while handling the food, wash fruits and vegetables thoroughly, especially those that will not be cooked. Clostridium botulinum is found in improperly canned foods, also in meat, ham, sausages, and some seafood. It again causes diarrhea, fevers, abdominal pain, loss of appetite, nausea. The prevention is again the same. Salmonella, again it is present in raw meats, poultry, milk, other dietary dairy products, raw eggs. Symptoms start, that is the incubation period, after 8 to 12 hours after eating, and include abdominal pain, diarrhea, and sometimes nausea and vomiting. Prevention is again cook poultry products to a temperature of 165 degrees Fahrenheit, avoid eating raw eggs. Staph aureus, it is mostly present in the poultry or dairy products like egg, raw salads, cream-filled pastries. Symptoms develop within 30 minutes to 8 hours after eating, which includes diarrhea, vomiting, nausea, abdominal pain. The prevention steps are again same: store food properly, cook or refrigerate or freeze the milk and poultry products, wash fruits and vegetables thoroughly. Again, Listeria, Shigella, again those are the source are the same. Symptoms, it varies from pathogens to pathogens. Some it ranges from 8 hours to 72 hours or even 14 days. The symptoms are again same: diarrhea, fever, abdominal pain, nausea, vomiting. These are the viral pathogens. Basically, hepatitis A spreads through oral fecal contacts when the hands are not washed properly when handling the food or food products. Symptoms begin with a loss of appetite, nausea, vomiting, and fever. Prevention are again the same. Rotavirus, it mostly happens in the children in the age group of below 0 to 5 years, which includes source at touch, including contaminated food, toys, and utensils. Fever for 3 to 7 days. Then there is a watery diarrhea. Norovirus, again same. Kleptosporidium, contaminated water. Occasionally food sources such as salads may serve as a vehicle for transmission. Giardia, person to person or through contaminated water, food surfaces or objects. Clinical symptoms, again it includes watery diarrhea, stomach cramps, abdominal cramps, nausea, vomiting, and dehydration. Prevention, practice good hygiene, avoid drinking contaminated water, wash thoroughly your hand before handling food or food products. Now, key principles of food hygiene by WHO. WHO has laid down some principles to avoid to maintain the food hygiene and avoid any contamination. Prevent pathogens from spreading from people, pets, and pests from contaminated food. Separate raw and cooked foods to avoid cross-contamination. To kill pathogens, cook foods for appropriate amount of time and at the appropriate temperature. Food should be stored at proper temperature. Use only safe and raw materials. Now coming to One Health, as I was telling you. One Health is an integrated, unifying approach that aims to sustainably balance and optimize the health of human, animal, and ecosystem. It recognizes the health of humans, domestic and wild animals, plants, and the wider environment, which are closely linked and interdependent. Why One Health should be an approach in food safety and food hygiene? In the current scenario, it is well recognized that human health is closely connected to animal and environment. So human health is now not restricted to human. We are taking lot of animal products. We are taking the products from the environment. So if there is any kind of disease or any kind of contamination in the animal or in the environment, there is a chance of contamination to cross over or spill over to human beings. Rapid globalization, increase in population, and environmental degradation has increased the complexity of threat to public health system. Inappropriate use of antibiotics in livestock industry largely contributed to AMR, and rapid emergence of zoonotic disease is anticipated to the encroachment in wildlife habitat. COVID-19 pandemic in 2020 and the Nipah outbreak in 2019 revealed that no public health emergency is a local problem. So, sir, so if we have a infection, suppose in Kerala, there was a Nipah outbreak. So people sitting in West Bengal may think, oh, it happened in Kerala, why we should bother? Let them suffer. It may not come here. But there is, the COVID-19 has taught us that there is no public health emergency is a local problem. It has transported or transferred from China to Russia, to Thailand, to India, and then in March, it was declared a public health emergency of global concern. Emerging health risks must be addressed using a multi-sectoral approach, engaging experts from human health, veterinary medicine, environment, infectious disease expert, epidemiologists, agriculture, wildlife, plant health, and policymakers. So comparing three different approaches to health. Earlier, global health approach, which mostly concentrated on prioritizing human health, where, for example, antimicrobial resistance tackled by limiting antimicrobial use in hospitals or over-the-counter use. Veterinary health, where it mainly concentrated on prioritizing animal health, and they mostly like AMR in animals was tackled by limiting antimicrobial use on veterinary or livestock. So how One Health? One Health aims to co-prioritize human health, animal health and ecosystem health. Like AMR in humans can be tackled by limiting animal drug use and environmental contamination, accounting for social, ecological and cultural determinants of uses. Now, scientific roots of One Health. One Health was conceptualized back into the 18th century, when the cowpox inoculation protected humans from smallpox. So there it was understood that something which can be treated, which can be used to treat animals, can also be used to treat humans. So that time people thought, okay, comparative anatomy, pathology and medicine. In that, something treatment which can be done for veterinary can also be used for human. In 19th century, based on the outbreak of anthrax and rabies, the concept of zoonotic disease was recognized. In 20th century, integrated health centers were formed. 1946, CDC established a veterinary public health extended into the WHO, and the one medicine was termed. In 21st century, based on the outbreaks of SARS, MERS, swine flu, avian influenza, Ebola, One World, One Health was again termed. In 21st century, the One Health Initiative and One Health Commission was formed, and in 2022, recognizing the post-outbreak of COVID-19, the One Health high-level panel of experts were formed with a quadripartite formation of WHO, WAO, FAO and UNEP. Why One Health approach in food safety? One Health, as I told you, it is a multi-stakeholders responsibility, where people, officials, administration from multi-stakeholders, from veterinary, from human health, from administration, from environmental experts, from engineering, from public health, all come together and share their information, which can greatly contribute to the improvement in food safety and public health. It relies on authentic data which they generate on occurrence and disease burden from foodborne hazards through a systemic surveillance system, because in the surveillance system in India is mostly managed by IDSP. It is a integrated disease surveillance program run by Government of India, where they have instrumentalized a surveillance mechanism to which red flag, if any small case of any unusual disease comes up, it starts from ASA or Anganwadi. It goes up from the step up to the higher officials. And they share their knowledge of source of attribution, which will be crucial in assessing the cost and benefit of the various intervention strategies. Because suppose there is an outbreak of avian influenza. So suppose in China they have avian influenza outbreak every, I think, alternate year. So they have an intervention package or intervention strategy. So when if in India, if some part of India, if we use those intervention strategies, how far it will be cost effective and how far it is going to benefit the human being. So those information are shared. Adapting a One Health approach in ensuring food safety and food hygiene will allow all countries to detect and combat the emerging diseases at the human-animal environmental interface and address food-related public health emergencies. That One Health high-level expert committee has identified the key areas for action. Highly pathogenic avian influenza has been identified emerging zoonotic epidemic and pandemic. For neglected zoonotic disease, they have identified 2 diseases. For food safety hazard, they have identified bacterial pathogen as Campylobacter. Antimicrobial resistance, they have identified MRSA, that is methicillin resistant Staph aureus. And for environmental health, they have identified climate change, biodiversity loss and land use. And they have mostly concentrated on capacity building for these areas. Now coming to one of the biggest pandemic which has gone unrecognized over the years, and still we are not aware, it may be a biggest pandemic than COVID-19. So AMR, what is AMR? AMR occurs when any microorganism, be it bacteria, fungi, parasite, develop resistance to the antimicrobial that we use, that is in practice. Those are antibiotics, be it antifungal, be it antimalarial. So AMR is proportional to the amount of antimicrobial use per person in livestock animals. Unregulated or excessive use in humans and livestock, aquaculture and agriculture accelerates the emergence of and transmission of AMR genes by exerting selective pressure on the resistance gene. So how many of you might have in this last 2 years have got COVID? Can you raise your hand? None of you got COVID? Okay, so you don't want to tell. So how many of you had taken azithromycin and thought, oh, you haven't got COVID, but you have taken azithromycin? You had COVID, so you have taken azithromycin, and you think it has treated you during COVID? Then why you took azithromycin? So azithromycin has been found to work zero effect on COVID-19 because and that time our beloved doctors had indiscriminately burdened the society with azithromycin. There was people mostly azithromycin has to be taken for maximum of 5 days. People were taking for 10-15 days. This has immense and this effect of this azithromycin uses or misuse will be realized in next 5 years when we will not have any drug to treat the very common diseases that we have or we encounter in the future. It has been established that or it has been recorded 5 million deaths in 2019 due to AMR pathogens, which is predicted to increase by 10 million by 2050. You can see in the map which has been done by WHO, and you see AMR is contributing to the highest of the mortality by 2050. Infections by AMR pathogens cause increased threat to the community. Which again burden the health system cost by increase the treatment cost and duration, because the common pathogens what we are infecting us, which were treatable earlier with the common antibiotics, are not working now. So we are according to various higher antibiotics, costly antibiotics, which is thereby exerting pressure on the health system cost. And this AMR could cost around 300 billion which may increase to 3.4 trillion annually by 2050 worldwide. It again will increase the mortality and morbidity by various infectious diseases. Animal food, which is a major contributing factor to the availability of cheap animal food source. The antibiotic is used for the growth promotion, disease prevention, and secondarily used for disease treatment. Poor animal welfare conditions increase the need of antimicrobials. Lack of access to pathogen and animal-specific antimicrobials contributes to poor welfare. Alternatives to antimicrobials like vaccines, improved biosecurity, animal welfare, and nutrition is not in place. We have very limited vaccines. We have vaccines for anthrax or in livestock, but we don't have vaccines for human. Total antimicrobial consumption in animals in 28 countries is estimated to be 63.151 tons, which is projected to rise by 67% by 2030 and nearly 100% in these countries: Brazil, Russia, India, China, and South Africa. Antimicrobial pollution again from the various pharmaceutical industries, manufacturing industries are polluting the environment. Human waste, large volumes enter waterways and other ecosystems, exposes a wide range of microorganisms to antimicrobial resistant genetic material, increasing the likelihood of AMR emergence. And there again a big problem is the horizontal gene transfer which occurs, which makes a non-pathogenic or non-virulent organism to a pathogenic organism when there is transfer of certain genes. So how do we ensure antibiotic access for humans and livestock while reducing the drivers of AMR emergence? managing AMR requires biosecurity, a proper surveillance system, drug research and discovery, drugs tailored to specific pathogens to prevent overuse or reuse, improved animal welfare, and some regulations, which is the most important part, some regulation of pharmaceutical productions, waste management, and over-the-counter sale of antibiotics. A One Health approach will consider the following: tackling the core problem, excessive and non-specific use of antibiotics, access for public health, food security, and ecosystem health, decision-making processes, actions across temporal and geographical scales, interdisciplinary and transdisciplinary use of antibiotics. WHO Global Strategy for Food Safety 2022 and 2030. In 2020, a resolution titled Strengthening Efforts on Food Safety was adopted by the 73rd World Health Assembly. In the resolution, member states requested WHO to update the WHO Global Strategy for Food Safety to address current and emerging challenges, incorporate new technologies, and include innovative approaches for strengthening food safety systems, and to submit a report for consideration by the 75th World Health Assembly in 2022. A draft in that format on that line was formulated and was placed on the food safety, safer food for better health. The vision of the draft strategy is to ensure that all people everywhere consume safe and healthy food so as to reduce the burden of foodborne illnesses. So with this I end my presentation. Sir, you had asked one question that some women or some mothers are now going towards feeding this canned food or formula food for their babies. So actually WHO has very categorically told it is not recommended for use for newborns. But in my presentation I showed you this, when you in this making of this formula milk, there is a use of water, which is the most common source of contamination. So if the food, if the water is not properly sterilized, again there is a handling of the water by the mother or someone else who is making the formula feed. So when you feed the baby, when in the first 6 months, this formula feed, there are chances of getting contaminated, entering of another microorganism into them, and thereby causing illness and thereby increasing mortality.
Anyway, thank you very much, Dr. Bhattacharya, for your nice and illuminating presentation. His deliberation is now open for a very brief interactive session. And Dr. Bhattacharya, as usual, I would like to take the first chance with two stupid questions. First thing, does this puchka or pani puri contain any bacteria? If so, what are those bacteria? And adding to this question, if it contains bacteria, different bacteria, why do the girls not suffer from stomach upset after taking 10, 20 or even 100 puchkas? Why only girls asking? Girls are not getting sick.
Sir, actually...
Okay. That was only for a photo shoot. Acha, my second question is, people say COVID-19 spread from some seafood market. What might be the food source for the spread of a virus which is normally spread through cup and through air?
Answering your first question, in making Odisha, your girls are not only very fond of fuchkas. In Odisha and Bhubaneswar I have seen, boys are lining up more than girls for the fuchka stalls. If sir was in Bhubaneswar, so sir may also second me. And in making fuchka,
including yourself?
I love fuchka. And I think all Bengalis love fuchka. And actually, in making fuchka, the most important ingredient is water. and that is source of contamination to n number of bacteria. So be it Vibrio cholerae, be it Shigella, be it Salmonella, be it Campylobacter. So it again depends. So pathogens are everywhere. Even now we are breathing pathogens. So that may not be have that threshold level that causing infection to us. Many of us might have got tuberculosis at some point of time, but our immune system is such good that it has combated it and removed it from our body. So it is not always that when we engulf or we take some bacteria, our natural immune system that we have, which is working continuously, has that capacity like that IgG and IgM, what sir was telling, to clear it up and control the infection. And your second question was COVID-19. So I'm a very small person to answer this, because WHO could not still now establish from where it spread, because our beloved neighbor country has never allowed a proper investigation of how COVID-19 spread, because they feel that they are because it was earlier thought that it was spread from some BSL-4 facility, it was synthetically manufactured, and it was even established that it never spread from that animal market, because samples were somehow got from there and tested, it never came out positive. So still it is a biggest mystery to be solved by the scientific community, that from where it spread. But definitely it has spread, it has some zoonotic origin, it has some veterinary lineage to it, and we must be prepared. Sir, there are so many theories around, because when we get, because some community has to work on that, and say they have to be in media, that suppose if I tell tomorrow it has COVID-19 has spread from Fuchka, so my big statement will come in newspaper all over in media, so I love that. So there are 100 theories or hypotheses. Even the Nipah has spread from the bats. So it is well established, because the half-eaten fruits which are falling in Kerala, they have been tested, and Nipah virus have been isolated from that. But for COVID, it has not been established from it has spread.
Any other question from anybody else?
Sir, I'm Dr. Vijay Kumar De, faculty DCS Salt Lake. I'm very much applauded that my abstract has been published here. But my humble question to you, your long PPT, as I notice, there are 3 divisions. Number 1, bacteria related and food contamination. Number 2, you have discussed 1, health. Number 3, antimicrobial consumption. There are 3 parts. 3 parts of your PPT, as I shortly noticed. But my humble question is that, as a domestic wife, a general person, what are the parameters to keep the cooked food from poisonous? Domestic wife, but what parameters are to be taken at my home? Number 3, when are we making food? What parameters are also taken to prevention it? And when we put the vegetables in fridge, what action would be taken? And not only that, sir also mentioned, in those sites, especially Kolkata, Sialda, one of the busiest station, Asia, Howrah, Namanno, Salt Lake Sector 5, and so many food sellers, and not only that, so many businessmen also helping it. So if we maintain that, the total system will be paralyzed something. So what's your suggestion? Thank you.
Sir, the homemakers that you're talking about, your beloved wife or anyone's beloved wife, actually the main precaution they should maintain to wash hand regularly while cooking, to wash the fruits and vegetables what you are bringing from market in proper water, clean water, cleaning of the utensils or the materials where food is stored properly. They should be raw, and fishes and all that should be stored after washing in the fridge, so that the temperature doesn't allow to growth of the microorganisms. Okay.
Sir, sometimes you notice the fishes are sold at market with mixing color. Even foods are mixing color. So what are the what shall we do?
See, this is entirely to be answered by an administrator or government policy makers, because we can generate scientific evidence. And at the end of the day, it is the administrator who has to regulate it is in place. The fishes or the food products, what you are talking about, Sialda or the office para of the famous Kolkata is the proper. If there are some programs run by the government of West Bengal to teach them the food hygiene and food sanitation. So they are teaching them, but it is at the end of the day the seller, the common people, who should be aware or who should be sensitized that if we take this kind of food or if we handle this in an unhygienic way, it may kill people. So and my customer flow may get lower. So it is entirely based on the reputation. If I continuously sell unhygienic food, people will not come to me. So, and again, it has the part, the responsibility of the government to run this proper sanitation hygienic program for teaching of these people.
Thank you, sir.
Thank you, Dr. Bhattacharya, for your kind participation and valuable deliberations. Now we shall have the final lecture from invited scientists in this session, in this conference rather. And our final invited speaker is Professor Madhumita Barua from Assam Agricultural University. On behalf of all people in the hall and all people of this college, I most cordially welcome Professor Barua to the stage and request our teachers to formally felicitate Professor Barua. Now it is my turn to formally introduce Professor Barua to everybody in the hall. Professor Barua is a professor in the Department of Agricultural Biotechnology in Assam Agricultural University in Jorhat, Assam. Professor Madhumita Barua is also the coordinator of research at the DBT Center of the same university. Her expertise circles around plant microbe interaction, food microbiology, gene sequencing and genetic engineering, and metagenomics. A major focus of her research has been to understand the health benefits of the traditional and ethnic fermented foods of the Northeast India. Many of her research publications have frequently been highlighted by different national and international electronic media, including the British Broadcasting Corporation. Moreover, Professor Barua has been featured as one of the topmost level scientists across the globe in the field of agricultural biotechnology. Professor Barua distinctly has a magnificent academic career. She got the prestigious Fulbright Fellowship for having her pre-doctoral training in Texas A&M University and Georgetown University in the United States of America. Subsequently, she became the owner of the prestigious Commonwealth Scholarship for carrying out her PhD work in University of Exeter in England. Later, she bagged Norman Borlaug Fellowship from the United States Department of Agriculture for carrying out her postdoctoral research work in University of Reading and Penn State University in the United States. Professor Borua has a wonderful research career. So far, Professor Borua has become the supervisor of around 20 research projects, resulting in award of PhD degree for as many as 40 plus students, research scholars, working under his supervision. To be true, the research output of Professor Borua is quite prolific. She has nearly 200 research publications to her credit, including scientific papers, reviews, and book chapters. One of her papers has come out in Science, which is one of the world's top-class scientific journals. Professor Borua is an editorial board member of different peer-reviewed journals. She is also a reviewer of several international scientific journals like PLOS One, Molecular Biology, Journal of Proteomics and Bioinformatics, Current Bioinformatics, etc. Moreover, she has been invited as the keynote speaker as well as resource person in numerous national and international conferences and symposia. Besides, Professor Borua is the owner of several prestigious awards in recognition of her contribution to research and academics. Some of these awards include Dr. Rajendra Prasad Excellence Award from Society of Tropical Agriculture, New Delhi. Others, Vidya Saraswati Rashtriya Puraskar from the Global Management Council, Lifetime Achievement Award from John Jagriti Seva Samiti, Kanpur, etc. Today, Professor Borua will enrich us with her deliberations on fermented culinary traditions, a gateway to functional foods and health resilience. On behalf of everyone in the hall, I cordially welcome Professor Borua to start her deliberations. A big hand for Professor Borua.
This is forward. Forward. Reverse. Yeah. Okay. This is what? Pointer. Okay. Thank you. A very good afternoon, respected Chairman, sir, on the dais, esteemed colleagues, and dear students. At the very outset, a very happy Foundation Day to the college, and I'm so humbled and privileged that you have invited me to be a part of your celebration. So thank you so much. As the chairman said, today my talk will concentrate on the traditional fermented foods of the Northeast and how they can be categorized as functional food. Because we've been talking about foods, we've been talking about the functional properties of the food, various new foods, but our humble traditional fermented foods are also a source of various bioactive compounds which have not received the scientific validation that they need. So food fermentation, we all know it's one of the oldest culinary technique for food preservation and nutritional enrichment. And they are integral part of the human diet. They have been an integral part of the human diet. And this art of food preservation and enrichment developed by the multifaceted ethnic communities of the Northeast India. The Northeast India is not one single entity, but there are so many different ethnic tribes within this Northeast India. And each of these communities and the tribes have their own system of preserving the food through fermentation. So there are about 250 different types of fermented foods and alcoholic beverage in the Northeast India. And these are very strongly linked to our culture and tradition. So what does fermentation do? It not only preserves food, it adds value addition, and also useful enzymes, amino acids, vitamins are also enhanced in the fermented foods. Then also there is a sensory enhancement. There is a modulation of the food texture. We know that the food, when it is fermented, the texture becomes different. So there is a modulation in the food texture. And also microbial enzymes like pectinase, cellulase also get deactivated in that.
You can use this microphone.
Okay. Sorry. And they, is it working? Am I, okay, I'll just talk like that, it's fine. It's okay, we'll just do it like that. So they also improve the digestibility and bioavailability of nutrients. The removal of undesirable factors like phytase that my predecessors talked about it. There is also removal of endogenous toxin, phytase, and unnecessary secondary metabolites from the food. So this Northeast India is the abode of many biodiverse fruits and vegetables all across. So many of these fruits and vegetables have also received the GI tag, like the Teshpur lychee, the Bhut jolokia, or the ghost chilies of Nagaland. Then we have the big cardamoms, then we have Assam lemon and so on. So there we have lots of bioresources which are unique to this region. So the people have learned to use these bioresources as a food system. Now, as I mentioned earlier, that the Northeast region is abode of different tribes and ethnic communities. We have a total population, our tribal population of 25.81% of the total population in Northeast India. We have 145 tribal communities, and we have about 78 major tribes population, which is more than 5,000. So we have 7 sister states and a 1 brother state, that is the Sikkim, which constitutes the Northeast India. Now we have different types of fermented foods. Sinki, which is fermented, brassica leaves. Then Khorisa is a fermented bamboo shoots. It's very popular across all the Northeast region. We have Mesu, then we have curd, and we also have Poita Bhat, or as you call Panta Bhat. That is also some of the... Is it okay now? Okay. Am I audible? Okay, thank you. So I'll start off with Poita Bhat. I'll be talking about some fermented foods that we have worked on and to show how rich they are in bioactive compounds. So Poita Bhat, as it is called in Assamese, it's equally famous in many parts of the eastern and northeast India. And in fact, its popularity also goes to Bangladesh and Nepal, because wherever rice is grown, this Panta Bhat or the fermented rice is very popular. So what are the benefits of Poita Bhat? It is well known, till now it was well known that it degrades an anti-nutrition factors. There's an enhancement in the dietary nutrient content. It acts as a body cooler during summer. So in summer when the farmers go to the field, they take this as a meal, and also in the morning it's taken as a breakfast meal. It prevents constipation, it lowers blood pressure, maintains healthy intestine. It prevents gastrointestinal ailments like ulcers, and it also has sporophic or slipping-inducing effect if the fermentation goes beyond a certain time. So many of the people do not like to consume fermented Panta Bhat because they think it induces sleep, but there is a science behind it as well. I'll talk about it later. So basically, the preparation of Poita Bhat is very simple. You have cooked rice. Actually, what it was done previously, we did not have fridge, people did not have fridge in ancient times. So whatever rice was left over the dinner, it used to be soaked in water, covered, allowed to overnight, and it was next morning it was ready to be served. So usually it is 8 hours. 8 hours of fermentation period gives a good effect, but if it goes beyond 12 hours, that it goes into alcoholic fermentation, producing the soporific effect, that is sleeping effect. So fermentation of rice beyond 12 hours will produce sleeping effect, but less than that should not do that. So I'm basically a food microbiologist, so my interest was to look at, what are the microbial dynamics during the fermentation process and what is really happening in that. So what we found that during this process, there is a yeast population and bacterial population as well as mold. Of course, there was a mold population was there, but over the time period, after 12 hours, it gets decreased, whereas the lab increases over time. The yeast is also there, but the lab overtakes after 12 hours. And we also looked at the activity because we isolated some lactic acid bacteria from this, and we wanted to look at if they had phytase and amylase activity. So we found some good ones. Some of the strains did have some phytase activity. Amylase activity wasn't that great, but it was still there. And during this fermentation, we wanted to see what is happening because we already know that cereals contain anti-nutritional factors, and phytate is one anti-nutrition factor. What it does is it binds to the mineral and does not make it available to us, okay? So like calcium, magnesium, everything is there in the rice, but because the phytate is there, it is not available to us. The same goes for wheat, the same goes for millets and other things as well. So over the time period in the fermentation, we found that the pH gets decreased, the pH here gets decreased, and the phytic acid content also decreases simultaneously. So this results in increased availability of iron, potassium, magnesium, calcium, zinc, etc. Now if you look at this figure, you'll find a 0-hour time interval, the iron content was this much, but after 12 hours it increased to 1.35. Similarly also with other nutrients, with phosphorus, magnesium, calcium. So what it is related directly to the phytase enzymes secreted by the lactic acid bacteria, because they are decreasing the phytate and making these minerals available to us. Now, it is thought that rice is not good for a diabetic patient, because of the starch content. So we wanted to see if poitavat was also equally bad for a diabetic patient. So we wanted to look at the carbohydrate content, and we found that the carbohydrate content also decreases over time period. And also we looked at the supernatant. In the supernatant also, the carbohydrate content decreases, and the reducing sugar content also decreases over the time period. So indicating that a fermented pontabhite is more safer to a diabetic patient. That would be a common rice. During this fermentation process, the poitavat also has lot of short chain fatty acids are generated, like the acetic acid, lactic acid, citric acid, pyruvic acid. And these acetic acids are antibacterial property. It has antibacterial properties. The lactic acid also is an antioxidant. Citric acid is an energy metabolism, and pyruvic acid it's a nutritional supplement. So all these are bioactive compounds are also found in the poitavat or pontabhat. And we wanted to look at the lactic acid content, what is happening in the lactic acid content. And over the time period, we find that the lactic acid concentration increases both in the rice as well as in the supernatant. So that is why it's sour in taste, the fermented rice. We also looked at some other therapeutically and nutritionally important compounds, and we find that these are some of the compounds. Phytosterol, fumaric acid, and these compounds are, they have flavonoids. The first one is a flavonoid, which is important for cardiovascular and cerebrovascular protection. Campestol is a steroid derivative, prevents absorption of bad cholesterol and balances blood cholesterol level. then phytosterol, fumaric acid, etc. So all these compounds are there in the poita bhat. So you can say that poita bhat is a functional food because it contains many of these functional properties. So this is our work, with a summation of our work. We first published this work in Asian Journal of Chemistry, somewhere in 2016, I think. And later we were covered by Telegraph. Our story was covered by Telegraph. We were also interviewed by BBC Bangla because after Khoshwar, she got the second runners-up in Australian MasterChef. The poita bhat again received some attention. So that is when it was. And it was also covered by Bangladesh National Newspaper as well as DAY-2 in the United States. And recently, NISPAR also published a story on traditional food on poita bhat. So this is our story of poita bhat, just to show that the humble poita bhat, how nutritious and beneficial it is to us. So many of us will neglect that, saying that it is a poor woman's food or this thing, but it is not that. It in fact has a lot of nutrients as well as functional metabolites. Another fermented food which is very popular in our place is the fermented mustard seeds. So after the mustard seed is used to extract the oil, the leftover is fermented to produce condiments. So there are two condiments. So one is used karoli and kahodi. So in one we use khar and tekera. So two basic ingredients of these products which determine the type of fermentation, whether it's an acidic fermentation or an alkaline fermentation. And khar is an alkaline solution that is prepared from the matured banana dry leaf. So what we do, Musa parasitica, basically, we take the peels of the banana, dry them, and burn them in the fire and take the extract of this. So that's an alkaline. So it's a very popular dish in Assam. And that is mixed with the seeds to make the khar, the kahudi. And tekara again is a mangosteen, is Graciana pedunculata. So here it replaces for the acidic preparation. So basically simple, this thing, seeds of black or white mustards are soaked in water. They are drained and dried in the sun. And they are pounded with occasional addition of mustard oil. And the oily batter is either mixed with khar for alkaline or for acidic, it is mixed with the tekera or mangosteen. And it is made into small balls here. And they are wrapped with banana leaves and stored. And so this is allowed to ferment, and this is taken as a side dish, as a condiment. Now we were very keen to know what was the difference, because this is the same base substrate is same. It is just that we are adding acidic and an alkaline additive. So we found that there is a lot of difference in the microbial population in this. Sorry, I get this. So this is kahudi samples and these are the karoli samples. So you can see the microbial population. These are vary on both this. There are three samples here. So they vary. And they also vary in some of the bacterial family like the Bacilliaceae. This is the Palingocea and Barkidoceae. So these are some of the microbes that vary here. And we looked at the microbial metabolites in both this karoli and kahodi. And we find that there are certainly differences in the most common bacteria in karoli is the Licinobacillus, and whereas in kahodi it is the bacillus. And these are the compounds which are more associated with the kahodi, and these are some of the bioactive compounds which are more associated with karoli. And these are some other of the therapeutically and nutritionally important compounds that was also found in this, like cetosterol. It has a role in sterol metatransferal. And we have beta-cetosterol acetate. It has a role in fungal metabolite and plant metabolites and so on. This is another in kahodi. We have a sulfur allyl isothiocyanate. It has a role as a lacerator, a metabolite, and antimicrobial agent. Then synapine, it has a role at photosynthetic electron transport chain inhibitor. Then we have linoleic acid. It converts GLA to substances that have anti-inflammatory and anti-cancer effect, and so on. So this again is a summation of our work which was published in the Journal of Ethnic Foods, where we identification of functional properties of dominant lactic acid bacteria and kahudi. And we also published this in recently in Frontiers of Sustainable Food System. Additive pH determines the bacterial community composition metabolome. So this was the result of this. Then coming to another third important fermented food, which is very popular in the Northeast, it's the fermented bamboo shoots. It's known as Korisa, it's known by soy balm, it's known by different names in different parts of the region. So, you know, in Northeast India, we have nearly harbor about 90 species of bamboos, 41 of which are endemic to the region. So we have lots of. So besides, you know, bamboo is everywhere. It's a part of our culture. We make houses with that. We make furniture with that. And besides that, we also eat bamboo, but not the bamboo that you see it already, but the bamboo shoots. So these are some of the products of the bamboo shoots. Soy balm, it's in Manipur. Soydon, Padam is in Meghalaya. This is Meghalaya thing. And Soyjin is Arunachal. Hirin and Hiku, these are all Arunachal. Different tribes make different types of fermented bamboo shoot products. So basically the young bamboo shoots are taken, they are defoliated and washed, chopped or pounded either, and they are tightly packed in earthenware pots or in suga or hollow bamboo stem, because again we use a lot of bamboos also as a containers, which results in the formation of Korisa or any other products that I've just shown a picture of. Now, looking at the microbial population dynamics during fermentation of bacteria, we find that lactic acid bacteria population, although initially lactic acid bacteria is not there, eventually after 7 days their population increases. Whereas other yeast and all, they all get reduced. This is basically because the lactic acid bacteria, as you know, it produces bacteriocin, which inhibits the growth of other microorganisms. And we looked at the carbohydrate and the protein content. So mostly it has a lot of carbohydrates, about 96% of the carbohydrate is there, and about 4% protein. And we also looked at the magnesium and other mineral contents, zinc contents, so very quite low, but mostly it's potassium, very rich in potassium, followed by magnesium and iron. And we looked at the volatile compounds which are present in the bamboo shoots, and there are many compounds, out of which I've just selected few just to highlight. So this benzyl methanol for hydroxide, it's an antioxidant, antihistaminic. Then you have hexadecan, antioxidant, antibacterial activity. And this is again an octadecan, which is an antioxidant, anti-inflammatory compound. So all these compounds are generated in the fermented bamboo shoots. Then also there are organic acids, phenolics, and flavonoids. Again, not many of them, but among them you can see betaine again is an antioxidant. Then catharantin, it's an anti-cancer compound. So choline again, it regulates memory, foot muscle control, and other function. So you can see the bamboo shoots contain many of the compounds which have functional properties in our body. An interesting thing about bamboo shoot is that, you know, it contains hydrogen cyanide. The raw bamboo shoot contains hydrogen cyanide. Again, it's an anti-nutritional factor. And you know, hydrogen cyanide is a poison. So, but what happens during fermentation process, the hydrogen cyanide contains, we took different varieties of bamboo. This was an experiment that we did. And we find that after fermentation, this hydrogen cyanide contents also gets decreased. And I mentioned about this bacteria, lactobacillic acid producing bacteriocin. So we isolated some bacteria like Lactobacillus brevis, and we tested them against some food bacteria, pathogenic bacteria like Listeria monocytogenes. And we find that they have inhibitory activity against these food pathogens. So that way, they also have antibacterial property. And it was just an experiment to see what different acid produces at what pH and how their activity decreases or increases. So these are the reported health benefits of bamboo shoot products. It reduces cholesterol, as you can see. It prevents cancer, source of good bacteria. It contains probiotic bacteria. It protects the heart. It's an immune booster, controls weight, promotes digestion, lowers blood pressure. So a lot of benefits from our traditional fermented food. So this is again this thing of our publication that we produced this. We also worked on fish, which I'm not discussing here now. I know fermented fish is also very popular in West Bengal. So we also have a lot of fermented feeds in our place, and we worked also on that to see, but I'm not discussing that here. This is more related to a rice beer. Rice beer is very popular, or rice alcoholic beverage are very popular in the Northeast region. They are a part of the cultural milieu. Any traditional festival that we have, whether it's mourning someone's death or celebrating someone's arrival or a marriage, this is served. So we worked on this. I'll just be brief about it. This is how it is prepared. Usually it is glutinous rice is taken. It is steamed. It's sprayed on a bamboo mat, inoculated with a starter culture. It's mixed and put on an earthenware pot like this, allowed to ferment for 2 to 3 days. You get the rohi. So you can see this water. This is the rohi, which is diluted with water, decanted, and you get the rice wine or rice beer. So another one is you add ash to that. That is another method of producing this rice beer. I'll go into this. So we also looked at the microbial dynamics here, and we find that the yeast growth increases. And after 7 days, of course, it decreases. But anyway, the enterobacteria or any other molds, they all decrease during the fermentation process. The starter culture is a very important part of it, and we looked into the starter culture process. And these are some of the herbs that are added to the starter culture in preparation of the starter cultures. This is just an example. Different communities have different number of herbs. And these are starter culture of different communities that we collected, and we worked on that to see. And these are some of the metagenomic study we did with this isolated culture to see what microbes are there. Again, what basically we find that the fungi like Rhizopus dilemma, muco, it's a potential used in biomass conversion, aspergillus. So these kind of funguses are there which secrete the cellulase, they produce amylase to degrade the starch content in the rice. And also there are some yeast. So these are some of the yeast. And these are the yeast that produces, that converts the glucose into alcohol. This is a metabolic pathway that we looked into, the metabolic pathway of the bacteria, the fungi and the yeast that we isolated. Not go into that. But what I want to say here, I'm sorry. This is the product that we developed by taking this. And this has been now taken by 5 startup companies. So this is out in the market now from our technology. Some agriculture industry has sold this technology to 5 startup companies. And we did a brief Haz. This is a traditional, different communities call it by different. The home call it Haz. This has been marketed as Haz, Luklao, and so on. And we did this thing with the Japanese sake. And what you find, although our alcohol percentage is 10, the government of Assam has a heritage drink. It is marketed by Assam government as a heritage drink. And they regulate that the percentage of the alcohol should not go beyond 12%. So we isolated the yeast cultures, which only produces about 10% of alcohol, not more than that. So this we compared with this, and the Japanese market is already focused as 26 years. So we hope that, Haz also will come up to that level. Now, these are some challenges in the traditional foods and beverage. Though consumed widely, it lacks scientific validation, as I say, and we do not have clinical data. So the clinical data is lacking. Aseptic condition is not maintained, so there are obviously some hygiene issues are there with that. There is no uniformity of taste and nutrient levels, mainly because we are not using a defined starter culture. So once we use a defined starter culture, we can have a standard product which can be industrially marketed, and of course they have a short lifespan. So we can popularize these fermented food products by organizing heritage festivals, encourage restaurants and bars, I think we were talking about yesterday, to serve heritage products. We can obtain GI tags. In fact, Judima is one alcoholic rice-based alcoholic beverage which has been given the GI tag. Tourism industry again, creating back linkages between tourism and food drink production sectors, and training future food makers through scientific approach, which is very needed. And this is my team. without whose work and support I would not have been present here. So all thanks to my team here. They have some people come and go, but these are the ones that we develop with this. So thank you very much.
Thank you very much, madam, for your succinct and clearly understandable, informative lecture. Now, her deliberations are now open for a brief interactive session, which, as usual, I begin myself with 2 stupid questions from a layman. First thing is that, how is it possible that all the fermented foods cited by you are developing only beneficial microbes? Don't they ever grow some harmful or toxic microbe? This is my first question. Second question is, people say in West Bengal, but I have heard in villages, if you take panta bhat or poita bhat, you will grow fat. Is it true, or rather, is it due to, if it so happens really, is it due to these nutrients added by the microbes, or what is the truth? Is it a myth or truth?
Okay, so I'll answer your first question first, sir. You mentioned about if only beneficial microbes are there, why not unwanted microbes are not there? As you can see, I will give the example of choriza, fermented bamboo shoots. So when lactic acid bacteria concentration increases, it produces acid, and not all microbes can withstand the acidic condition. So they die out.
So harmful bacteria die?
They die. And moreover, the lactic acid produces bacteriocin. I'll just show the slide. So these bacteriocins are not antimicrobial. They are antimicrobial compounds, but they are proteinaceous in nature. Okay, so they kill the other harmful microbes. So that is why you can store this fermented bamboo shoots for a long, long time. But again, to answer your question, I've showed in the starter culture of the rice beer, we also have some unwanted microbes. When we did the metagenome analysis, yeah, sir, that is a problem. So it is always, not hygienic. As I mentioned in my last slide, it's not hygienic. Aseptic condition is not maintained. Because when the woman flock is concocting the starter culture, she may have some skin disease. We found some microbes which causes skin disease in the starter culture. So that is why it is very important to maintain the hygienic condition. What was the second question? Yeah, about this thing about whether it's a myth or this. I'm not very sure because we haven't done clinical studies on the obesity side.
Say you take panta bhat and grow fat.
I don't know about that, sir. As I said, we haven't done clinical studies or animal studies on that. But what I can say, definitely it's nutritious, and the carbohydrate content definitely goes down. No, it goes down in panta bhat. I've showed that the carbohydrate content over the fermentation time period, the carbohydrate content goes down, and lactic acid is more. So it's that way it's safe.
Any other question from anybody else? Any question from the students?
So, hello ma'am, this is Deep Chottoraj. I'm from Nutrition and Dietetics, PG first sem. Ma'am, basically I wanted to know that we are into a session where we have learned also in fermentation previously that it reduces the phytic acid in food. Ma'am, but also to the contrast, phytic acids do represent a category of antioxidants. And antioxidants are substances that balances the TP53 genes in our body to prevent any further free radical mechanism. So ma'am, if this cause reduces the phytic acids, so can we conclude that it also affects the antioxidant index of any sort of food?
It's a very good question. We haven't really done on the antioxidant properties, so I'll not be able to answer you. But what I can answer is that phytic, the phytate, it chelates the metabolites and doesn't make it bioavailable to us. So that is why it is considered as an anti-nutritional factor. Okay. Now, and coming to antioxidant, as you can see from this, some of my slides, you have n number of antioxidants that are produced. So even if the phytic acid is getting reduced, there are some other antioxidant which is compensating for the antioxidant properties. So I think that way they are balanced.
Can I make a point on it?
Yes, sir.
This is an addition actually. Actually, phytate or phytic acid, it prevents the absorption of many nutrients, particularly antioxidants. Some vitamins absorption cannot be possible if the phytic acid or phytate concentration is low in the food. Okay, so it is an advantage rather than disadvantage. Okay.
Okay.
Am I right?
Thank you.
Thank you, madam, very much for your nice deliberations.
A very big round of applause for that. Now it is, dear students, now it is time for lunch. We are having lunch break, and post-lunch session will begin after you come back. I request our principal, Dr. Sudipta Chakraborty, and Professor Dilip Nandi to accompany our invited scientists to the food court. Nijan. Come on.
Now it's the time for oral presentation session by our research scholar, and I would like to invite Dr. Nirmal Kumar Sarkar sir to chair this session. Sir, it is over to you.
We are starting the oral presentation session for the research scholars. Before starting, I would like to say something. First thing is that in order to ensure impartial judgment and to avoid all kinds of conflicts of interest, there will be a single adjudicator, and the adjudicator is none but Professor Madhumita Barua from Assam Agricultural University. One more thing, it is desirable that any teacher whose scholar or scholars are presenting papers or paper in this session should ask as less questions as possible in order to avoid all kinds of conflicts of interest and to ensure impartial judgment. And now I shall take the attendance of these scholars who are supposed to present papers. Priyanka Kaur, Songita Maiti, Sahadev Jana, Pratik Ghosh, Sahadev Jana, Songita Maiti, Pratik Ghosh, Purna Nandi, Purna Nandi, Riya Kaur, Raghunath Hajra, Tridip Kumar Das, Sanjay Das, Sanjay Das, Smita Ghosh, Pipika Das, Prashanto Patro, Pranoti Bera, Moumita Samanto, Saptorshi Mandal, Soham Roy, Shubhajit Mohanty, I repeat, Priyanka Kaur, respond please and loudly please. Songita Maiti, Sahadev Jana, Purna Nandi, Riya Kaur, Raghunath Hajra, Tridip Kumar Das, Sanjay Das, Smita Ghosh, Pipika Das, Prashanto Patro, Pranoti Bera, Moumita Samanto, Saptorshi Mandal, Soham Roy, Shubhajit Mohanty. A researcher will be given exactly 10 minutes, not more than 10 minutes. The less, the better. and exactly 5 minutes will be allowed for interaction. Exactly 10 minutes. You will verbally be cautioned at 8 minutes and finally stopped at 10 minutes. So, madam, would you like to sit over there only or like to be seated there? Okay, no problem. So, the first speaker, you will start only after you are advised to start. Understand? So, it is time for Priyanka Kaur, who will be presenting her paper on biocontrol of Vibrio harvae by bacteriophage VPMCC14, a member of a new genus under Cordovivicitus class. Priyanka Kaur. Feel comfortable?
Yes, sir.
You will start only when I advise to start.
Okay.
I wish you could arrange for water, drinking water. If any scholar feels nervous, it will be kind of you. ঠিক আছে? ওইখানে রেখে দাও। Madam, ready? So, এই কথা নয়। So, Priyanka Kaur is 12 minutes past 3 o'clock in my watch. Please start.
Good afternoon, everybody. Now I am going to present a part of my research work on biocontrol of Vibrio harvae by bacteriophage VPMCC14, a member of a new genus under Cordovivicitus class. Vibrio harvae is a gram-negative pathogenic bacterium. It is responsible for luminous vibriosis and mass mortality in shrimp aquaculture. To the control of this bacterial infection, shrimp farmer uses some antibiotics such as chloramphenicol, tetracycline, etc. But the uses of antibiotics have several problems. Vibrio harvae can resistance to these antibiotics. So there is need alternative of antibiotics for the controlling of Vibrio harvae infection in aquaculture environment. Bacteriophage have been suggested to be a substitute to the control of this bacterial infection. The main aim of this work is to biocontrol of Vibrio harvae, which is a detrimental pathogen in shrimp culture. The objectives are the isolation and characterization of Vibrio harvae infecting lytic bacteriophages, then whole genome sequence analysis, then application of Vibrio harvae infecting bacteriophage for controlling Vibrio harvae infection in shrimp in laboratory scale. These are the methodologies. First of all, 60 soil samples are collected from shrimp cultivation area of East Midnapore. Then it transported in laboratory. Then we tested the collected sample using by the Vibrio harvae as a host bacteria. Then we have isolated a bacteriophage which known as bacteriophage VPMCC14. In figure 4 showed that the transmission electron microscopy image of bacteriophage VPMCC14. The one-step growth curve of bacteriophage VPMCC14 exhibited that the latent period was 30 minutes and the highest burst size production was 38 PFU per cell. In liquid culture inhibition of bacteriophage VPMCC14 could control the Vibrio harvae at MOI 0.1 and MOI 1 after 4-hour and 5-hour incubation. It confirmed that the bacteriophage VPMCC14 have strong lytic activity against the Vibrio harvae bacteria. After the stability testing of bacteriophage VPMCC14, it could survive wide range of pH 3 to 9 and temperature 4 degree to 45 degrees centigrade and salinity up to 40 ppt, which suggests that the bacteriophage VP MCC14 could control the Vibrio harbor infection in aquaculture environment. The bacteriophage VP MCC14, the genome was sequenced from NIBMG Institute. Then we received a single FASTA file. Then we performed some bioinformatics analysis. The bacteriophage genome was annotated using by the Rust ORF Finder GeneMark software. This is the circular genomic view of bacteriophage VP MCC14. Some putative functional protein are labeled bacteriophage VP MCC14. Gene bank NCBI number is ON292990. When the bacteriophage VP MCC14 genome was compared with the 105 ICTB and NCBI reported Pidioviridae, Stravoviridae family and Gorgonviridae subfamily and some unclassified genus, resulting bacteriophage VP MCC14 clustered with the NCBI reported unclassified bacteriophages. It was constructed by using CLANS software package. The network was visualized after 28,262 run. The bacteriophage VP MCC14 genome was compared the blast and similarity reported Vibrio infecting bacteriophages using by the progressive MOB alignment. The color block indicated that the DNA sequence similarities. The phylogenetic analysis of bacteriophage VP MCC14 and some ICTV and NCBI reported Stravoviridae, Pidioviridae family and some Gorgonviridae subfamily, resulting the bacteriophage VP MCC14 branched with the unclassified family bacteriophages, major capsid protein and terminates large subunit protein. It was constructed by using phylogenetic free program. In figure C showed that the viridtic analysis of bacteriophage VP MCC14 and some closely related bacteriophages, it was indicated that the genome distance with bacteriophage VP MCC14. This is the table of genomic and proteomic features of bacteriophage VP MCC14 and some ICTB NCBI reported Pidioviridae, Stravoviridae family and some unclassified family bacteriophages. The bacteriophage VP MCC14 genome length was 1,34,470 base pair and guanine and cytosine content was 34.5%. The number of protein sequence was 240. The bacteriophage VP MCC14 highest genome sequence similarity was 18.54%. According to ICTP species genus demarcation criteria, below 70% genome similarity indicated that a new genus and below 95% genome similarity is indicated a new species. So bacteriophage VP MCC14 genome similarity is 18.54%. It might be a new genus. Above the comparative genomic analysis, CLANS, dot plot, progressive alignment, phylogenetic tree, viridtic analysis, genomic and proteomic analysis strongly suggest that bacteriophage VP MCC14 might be a new genus under Codoviricites class. When the bacteriophage VP MCC14 was applied in aquarium trial, the bacteriophage VP MCC14 could control the Vibrio harbor infection in aquarium water and reduce the mortality of shrimps. The conclusion of this work is the bacteriophage VP MCC14 significantly lowered down the number of Vibrio harbor in aquarium water and increased the survivability of Peneus monodon. The bacteriophage VP MCC14 could be applied in shrimp aquaculture as an alternative to antibiotics. These are all the references. Then thank you.
Now you will have to face a very brief interactive session.
Yes, sir.
And it is valid for all researchers. At first you have to interact with adjudicators. She will be the first person to
Yes,
give
sir.
her impression and to ask you something, which you should take in a friendly manner. And then I shall be inviting students, not more than 2 questions. And then I shall be teachers, and that is also not more than 2%. So, madam.
Thank you, sir. Priyanka,
Yes,
good
ma'am.
presentation, good work. I was just wondering one question. How did you initially isolate this bacteriophage? I think you didn't mention
First
very
of all, we have collected some aquaculture sample. Then we performed some laboratory work such as bacteriophage isolation process, which is the process was 20 ml nutrient broth mixed with overnight grown Vibrio herbae culture and incubated 18 hours. Next day we performed dotting assay process. Then the bacteriophage will be isolated.
So the plaques, where you found the plaques, you assume that it was because of the bacteriophage infection. Was it that?
Yes.
Okay.
Now, anyone from students or scholars? Any question? Any question from teachers? So I take it for granted that adjudicators' decision time is there. Her decision will be final. So thank you very much
Thank you, sir.
for taking this challenge. Now be seated, please. And I invite the next speaker, Ms. Shongita Maiti. Go there. Feel comfortable first. She will be presenting a paper on immunomodulatory role of SNP-AP-AGP in experimental tuberculosis in vitro. Feeling comfortable or feeling nervous?
Yes, sir.
Ready to start?
Yes.
Wait. The scholar will start only after I say you start. Okay? It is 3:22 in my watch. So it's time to start.
Good afternoon, everyone. I am presenting a presentation about immunomodulatory role of SNP-AP-AGP in experimental tuberculosis in vitro. First of all, I want to say that tuberculosis is a major public health problem, is a highly contagious and airborne infectious disease caused by Mycobacterium tuberculosis. Mycobacterium tuberculosis is known as Koch's bacilli because 1882 German scientist Robert Koch discovered this rod-shaped bacteria. According to WHO, 2023, every year about 10 million people are suffering from this disease and 1.6 million people are die of it. Tuberculosis is transmitted from an infected to a susceptible person through the air droplet by nasal cavity and to reach the alveolar macrophage of lungs and reside there. But we all know that as macrophage cells are an immune cell, so it can easily clear the pathogen by the phagocytosis. But how it survive within the macrophage and causes of pathogenesis? Actually, there are few virulent factors of MTB which can inhibit the phagolysosomal maturation and can prevent the phagocytosis. And there, within the macrophage, there are two vital pathways. One is the arginase pathway and the inose pathway, which can by the arginase pathway, MTB can survive within the macrophage, and inose pathway MTB can kill within the macrophage. As we know that tuberculosis is a life-threatening disease, so there are many conventional treatment options. Nowadays, the main conventional treatment is the antibiotic therapy, such as the first-line drug like rifampicin, isoniazid, etc., and the second-line drug which is the levofloxacin, etc. and still the day the scientists are investigating a more better treatment approach due to their drug resistant strain, because of the longer duration of administration, large doses, and the use of antibiotics at once. So to avoid the drug resistant strain, the use of host directed therapy is a appreciable approach. It can be effective for drug resistance and drug susceptible bacteria. In the field of host directed therapy, the immunomodulators such as isolated compound or synthetic compound can play pivotal role to boost up the host immunity. So in this study, we are trying to explore the isolated compound arabinogalactan protein, which is extracted from Endographis paniculata, and through the silver nanoparticle based delivery system on the against the tuberculosis model. There are many biological activity. So nowadays the main therapeutic target is the toll-like receptor, which can control the anti and pro-inflammatory cytokines that can control the tuberculosis pathogenesis. And there are few virulent factors which are directly interact with the TLR, and they can activate the NF, kappa B, and AP1 transcription factor by the MYD88 pathway, and can produce the anti-inflammatory cytokines. And in this study, we are trying to explore the activity of SNP-APAGP to modulate the toll-like receptor for the heal up the pathogenesis. So in this study, my aim is to study the efficacy of SNP-APAGP through the TLR-mediated immunomodulatory role against tuberculosis model. To fulfill my aim, my first objective is to prepare and characterize the SNP-APAGP, and second is the examine the immunomodulatory activity after the treatment of SNP-APAGP, and thirdly to study the all TLR expression in the MTB infected macrophage after the treatment with SNP-APAGP. And it is the overall design of experiment. And earlier first I mentioned that I isolated arabinogalactan protein, and then from there I prepared silver nanoparticle, where we found a sharp peak at 423 nanometer by the UV visible spectral scanning, and by the TEM image we found about 20 nanometer of our particles. And we also determined the non-cytotoxic dose of APAGP and SNP-APAGP, and where we found that up to 2.5 microgram per ml there are no significant difference, and at 5 microgram per ml slightly decreased the cell viability, and at the 10 microgram per ml the cell viability is significantly decreased. We also quantified the viability of H37RA, where we found that at 2.5 microgram per ml the cell bacterial load is significantly reduced compared with the control. And we also checked the nitric oxide generation, where we found that 2.5 microgram per ml it is significantly increased compared with the control. And we also checked INOS2, IFN gamma, and arginase-1, where we found that INOS2 is significantly decreased during the infection compared with the control, and it is increased during the SNP-APAGP treatment. And IFN gamma and arginase-1 is decreased during the infection compared with the control, and it is increased. IFN gamma is increased during the SNP-APAGP treatment, and but arginase-1 is decreased during the SNP-APAGP treatment. We also checked pro-inflammatory and anti-inflammatory cytokine, where we found that the mRNA expression of IL-6 which is there is no significant difference with the uninfected control during the infection, and it is increased when it is treated with SNP APAGP, and the anti-inflammatory cytokine interleukin 10 is increased when, during the infection, and it is decreased and during the SNP APAGP treatment compared with the infected control. And we also checked the M1 and M2 marker, where we found that M1 marker is there is no significant difference compared with the uninfected control, and it is increased during the SNP APAGP treatment, and M2 marker is increased during the infection, and it is decreased during the SNP APAGP treatment compared with the control. And we also checked all TLRs, where we found that TLR 1 and 3 is increased during the treatment, during the infection, and during the treatment with SNP APAGP they are increased, they are decreased, and TLR 2, 4, TLR 2, 4 and 5, there are no significant difference, and they are increased during the treatment. And TLR 8, 9, 11, 12 and 13, there are no significant difference during the infection, and during the treatment SNP APAGP is increased. So from this study we found that the M2 markers and anti-inflammatory cytokines and most of the TLR 2, 4, 6, 9, 11, 12 and 13 are increased during the SNP APAGP treatment, which are the indication of the heal up the pathogenesis of tuberculosis. So we can summarize from here that we can be apply this SNP APAGP for the treatment as a host directed therapy as a on against tuberculosis infection. These are references. Thank you.
Again, a very interesting work that you have done. But I was just wondering, why did you take silver nanoparticles for generation of the nanoparticles? Why didn't you not take some more friendly green particles, green nanoparticles? Why did you not go for those? Because we already know yes, they are known to have, nanoparticles are known to have, silver nanoparticles are known to have antimicrobial properties as well. But although you have shown that, there was not much of effect on cell viability, but you see in high concentration, the cell viability decreased, right? And on the long run, we still do not know the effect of silver nanoparticles. So what made you choose silver nanoparticles rather than more friendlier particles? Biological particle for generation of this nanoparticles?
Because it is the silver nanoparticle, it is already reported that it is more efficient than other nanoparticles, and it is a nano formulation first, so it can easily deliver within a host, so we can apply this.
Okay.
Any other question from anyone else?
In the plant. Obviously, you form the green synthesis of the nanoparticle. That's one is the very good. But one thing, why use silver? This is most important. And why use silver? As because silver is very much toxic in our body. One. My humble questions to you, not a questions, whether it is a experimentally induced by tuberculosis in the animal model
Or natural.
or cells, say the human beings, or it is already in vitro study, and obviously in vitro study, not in use the animal.
No.
That's why you may consider as the in vitro study in the laboratory, only for the bacterial. That's why you may use. If you use for the, it is suggested in the future times as a form of a drug or the others, as a silver nanoparticle is applicable for the controlling the tuberculosis. Or not? It is possible to develop any type of drug. It is possible or viable. This is most important. Okay? That will be the better. Okay, thank you very much.
Thank you.
Very good, very good.
Thank you, sir.
Our third speaker is Sri Shahadev Jana. He will be presenting his paper on effect of chloroform action of asparagus racemosus roots against cisplatin-induced nephrotoxicity in male albino rats. Are you ready?
Yes, sir. Start, sir. No, sir. Sorry, sir.
So, it is 3:37 and your time starts now.
I want to gratitude to my respected Dean sir and Nirmal sir and Dr. Madam, and to present here my research work, and entitled is the effect of asparagus racemosus, chloroform faction of asparagus racemosus roots against cisplatin-induced nephrotoxicity in male albino rats. I am a Sahaj Bana research scholar of Midnapore City College under the supervision of Dr. Suchimita Roy. Now I will present my research work. Background of my research work: acquired kidney injury and chronic kidney injury have become a worldwide public health problem and ranked with the 9th leading cause of the death 2019 per year. And CKD is a condition that gradually reduces the both kidneys over time and increase patient morbidity and mortality risk. CKD ultimately result in end-stage renal disease, an untreatable condition by which the complication of end-stage renal disease and dialysis and kidney transplantation is much expensive or difficulties for health treatment. And initially there are no symptoms to diagnose early stage of kidney disease. And here we choose the cisplatin. Cisplatin is a chemotherapeutic drug, and it prevent the including the cancer like cervix and lungs and the ovary also. And cisplatin is prescribed 10 to 20% of all cancer patients due to its efficacy of cancer, slowing growth, cancer growth, and renal uptake, and the and excretion of the medullary of the proximal tubule, and transporter, localized transporters such as OCT, OCT2 and OCT2 and MAT1 is the localized transporter, and it's the activation of the MAPK, and the cisplatin is the nephrotoxic drug, can cause the oxidative stress and disrupting the homeostasis mechanism, and increase the antioxidant free radicals production and decrease the antioxidant defense system. Now the oxidative stress damage DNA, thereby inhibitory effect of anti-apoptotic protein upon the pro-apoptotic protein. So pro-apoptotic protein family like BCL2, BCLXL are free to form oligomeric channel. Through which the cytochrome C, and cytochrome C is the bind to the APF1, and APF1 also the ATP bind and to form the apoptosome, and it is apoptosome, and it is the and it is the form of the cascade system and leading cause the apoptosis.
I did not say anything to you. I did not say anything to you. This is
Now the asparagus resmosa, which here the plant asparagus resmosa. Asparagus resmosa is a medicinal plant, and it's available in locally market West Bengal at Midnapore district. And the asparagus resmosa is a medicinal wealth, having the medicinal wealth plant, and roots is the top of the list. And asparagus resmosa is a well documented medicinal plant. It's traditionally using the medicinal system such as the Ayurveda and Siddha. And the asparagus resmosa is the highly content of the phytocompounds like phenol, flavonoid, and such as the which prevent the vigor, vitality, and impart immunity and improve the mental function and immunomodulatory effect. And now the asparagus resmosa is in contrast, it is the tonic for the traditionally application, usually the antioxidant, anti-tumor, anti-cancer, anti-ulcer, anti-diabetic, anti-hepatic, and anti-hypercholesterolemia and immunomodulatory effect also. Now aim of my research work to search out the effect of chloroform faction of asparagus resmosa roots cisplatin induced renal failure in rats by dose dependent studies. Now here we can say that the one side is the cisplatin 10 mg per kg body weight. We inject intraperitoneal injection of cisplatin. Then oxidative stress was increased and inflammation and glomerular and renal tubular injury also increased. Then the biochemical parameter were significantly decreased, like the GSH antioxidant enzyme, the GSH and SOD, and biochemical parameter like the functional biochemical parameter, blood urea nitrogen and serum creatinine level was significantly increased. And now the kidney injury marker like Kim1, Bengal, and nephrin, there was the significant increase, but nephrin is significantly decreased. We can say previously come to the point. Okay. Now the another side we can say that the asparagus resmosa extract we prepared first. Then chloroform fraction was given at 15 days treated orally feed of rats. Then we can say that the inhibit of the antioxidant were inhibit the oxidative stress, inflammation, and glomerular and renal tubular injury. Then the when we treated the chloroform faction of asparagus resmosa, then the antioxidant is the increase and SOD level is increased, and blood urea nitrogen was decreased and cystatin C was decreased. Same likely the Kim1, Bengal, and NFKB was decreased. Now we had to choose the chloroform faction. Why chloroform faction? We choose the we treated the asparagus. We treated the rats. Now the chloroform faction was LCMS analysis for characterization of the phytocompounds present in asparagus resmosa of chloroform faction. Now the chloroform faction was presently many possibly bioactive phytocompounds like the longifilol, flavon, and serengic acid, also orientin, etc. Now experimental design of my research work. First we choose the 36 rats. 36 are divided into 6 groups. First group is the control group. Control group served as the normal food and water is available. And second group is the vehicle control group like chloroform faction. And uremic group was the third group. The 10 mg per kg body weight cisplatin induced. And the group 4, 5, and 6 group were treated the orally feed of asparagus resmosa, different dose 50 mg, 100 mg, and 200 mg, and after cisplatin injection at 10th day of experiment. After rats were sacrificed and 16 days, then we analyzed the biochemical test and the gene expression like PCR, RT-PCR, and the histopathological analysis for the confirmation studies. Then result part of my research work. First we observed that the body weight, first we symptoms observed the body weight was significantly decreased as compared to the control group, but here control group was the 154.35 was finally after 15 days the finally 177.60. Then we treated the CP group 10 mg per kg body weight. The significantly normally is the final days is the 150.75. But we concluded that the cisplatin is effective as compared to the control group. But we treated the chloroform fraction of asparagus response at different dose. Then 50 mg, 100 mg and 200 mg significantly increased as compared to the cisplatin group. Now we represent that the relative kidney weight and renal somatic index also, and relative kidney weight when we analyze the relative kidney weight. Relative kidney weight, kidney was we measured that kidney weight is increased because of the kidney is the hypertrophy. Like when cisplatin treated the kidney where weight is around 2 gram, and the cisplatin treated rat, then when we treated the 50 mg and 100 mg and 200 mg were significantly decreased as compared to the CP group. But the renal somatic index were measured when the kidney weight and divided by the rat weight and multiply into the 100. Then we analysis the somatic index, renal somatic index. Here we conclude that the CP treated group is the renal somatic index is increased as compared to the control group, and when we treated the chloroform fraction different dose 50, 100 and 200 mg per kg body weight was significantly decreased. Now the functional group of kidney injury marker like blood urinary and serum creatinine level were when we can see that the CP treated rat was significantly increased as compared to the control group, and the different fraction were significantly decreased as compared to the CP treated rat. And cystatin C and KIM1 is the kidney injury marker, kidney injury biomarker. When kidney injury of the glomerular tubular injury, that times the release the cystatin C and KIM1. We analyze the urinary KIM1 and cystatin C. When we can say that we observe that the cisplatin is increased as compared to the control group, and different dose of fraction were treated. There was a significantly decrease as compared to the CP treated rat. Here KIM1 is the same like just. And antioxidant defense system we were analyzed to determine by using the kidney tissue, and GSH and SOD. GSH is the antioxidant defense system. When we treated the chloroform fraction, the free radicals production is decreased and antioxidant defense system is free radicals production is increased and the antioxidant defense system is decreased. Then we checked the cisplatin injection. There was the significantly decrease as compared to the control group, and when we treated the different dose, then we saw the conclude that the different dose of chloroform fraction was significantly increased as compared to the CP treated rat. Then where we present the relative kidney weight, mRNA expression of NGAL, KIM1 and NFKB. NGAL KIM1 was the KIM1 is the inflammatory marker of kidney injury molecule, and NFKB is the central mediators of the inflammation and fundamentally involved in the molecular level of the inflammation and thrombotic process. And KIM1 is the KIM1 is the inflammatory marker, and then we observed that the mRNA expression level of cisplatin was significantly increased as compared to the control group, and when we treated the asparagus responses at different dose, the mRNA expression level was significantly decreased as compared to the CP treated rat. Then we say here the KIM1 and NGAL also. Then nephrin is a key molecule of the podocyte, and the normal slit diaphragm, and nephrin is the interact with the podocyte layer of many podocytes. Then NRF2 expression is the cellular antioxidant defense system. When the cisplatin treated, the antioxidant defense system was cellular antioxidant defense were significantly increased as compared to the control group. But we treated the chloroform fraction at different dose, the significantly increased as compared to the CP treated rat. And also the apoptosis mechanism also we marker using the testing for the apoptosis. The BCL2 when apoptosis, the cisplatin was significantly decreased BCL2 marker. Then when we down regulated the BCL2, then P53 is the upregulated. Then this is the histological parameter using the kidney tissue. And first, as shown in figure 6, the control group were.
Very sorry. After all, this is the competition. So I feel sorry to divert you from continuing. Competition is competition. Hard time for this time. Wish you good luck for the next time. Madam, please interact with him. On extra from me.
You have done extensive work, very interesting. What is interesting to know that whenever you have added the fraction, that racemose, you have seen the antioxidants go up. And I was just wondering, you have taken chloroform extract. Why?
Yes,
did you try some other extract as well?
Yes, ma'am.
So among what extract did you try?
So methanol fraction, ma'am, or ethanol fraction, and chloroform fraction is the first of all, ma'am. I clinically trial the TLC and flavonoid HPLC. Then we choose the chloroform fraction. Is the many compound present in the chloroform fraction, many phytocompounds. So we choose the chloroform fraction. Is the better, maybe better result, ma'am.
Okay. Okay.
Any other question from anyone else? Thank you.
Hello, sir. I am Anushree Patro, a PG student of zoology in this college. So you. Hello.
Loudly, please.
Hello. Sir, you have told about Asparagus racemosus, a plant.
Yes.
So I am little confused about you have told about the beneficial effects of this plant.
Yes.
So it has any prevention effect or any cure effect for diabetic patient? As an example, I am saying a patient who is a diabetic patient, if he consumes this plant every day in his diet,
yes.
So there is any result, as a resultant he will be cured or not, or if the plant is consumed day by day or he is not a diabetic patient,
yes,
then he will be prevented or not. So my question is, it acts as a prevention or cure of the diabetes?
Prevention, like cure, not cure. Asparagus racemosus is a plant, medicinal plant, and we treated the chloroform fraction, we treated the different preparation, and yes, obviously it is the cure, not cure, it's the prevention. And many diseases we don't know the cure, we do not cure because it is not medicinal. Okay, ma'am. So we prevalence, not treated, not prevent, prevalence. Okay.
Okay, so a question arises that there is high expense in the curity or in the cure of the diabetes, like dialysis and other kidney treatments. So it has no effects in there.
No. এটা হচ্ছে কি, দেখো তুমি যেটা বলছো যে আমি yes nephro.
This question is not pertinent. He has not discussed anything on diabetes. Is Pratik Ghosh present? Did Pratik Ghosh turn up? No. Purna Nandi. She will be presenting a paper on bioefficacy of Ganoderma lucidum, supplementation for better health efficiency. Wait, please, and feel comfortable until you are advised to start.
স্যার নিজের বারণ করেন।
Bioefficacy of Ganoderma lucidum supplementation for better health efficiency.
Shall I start, sir? Shall I start?
Did I advise you?
No.
Then keep short.
Okay.
Silence, please. You can start now. It is 3:55.
Okay.
Please start.
Thank you. Good afternoon to all the respected sir and madam and all of you. I am Purnanundi, research scholar from Raja Narendra Lal Khan Women's College, and today I will discuss about the bioefficacy of Ganoderma lucidium supplementation for better health efficiency. So Ganoderma lucidium is a polypore mushroom with its more than 200 bioactive components. There is also presence of aspartic acid, different amino acid, crude fat, starch, protein, but the most important and abundant bioactive components are polysaccharide and triterpenes, which are involved in many physiological processes, like it can block the angiogenesis, ROS production, it reduces the inflammation, and also involved in and can enhance the anti-tumor activity. So for its more than 200 bioactive components, it involved in many therapeutic activities, like it has anti-ulcer effect, anti-cancer, anti-inflammatory, sorry, sir, immunomodulatory effect, anti-cancer, and the most important, antibacterial effect. So the Ganoderma lucidium can affect on gut microbiota. For focusing on the gut microbiota, reason is because gut microbiota is the large part of our human body. In our gut, the microbial cells are present more than the normal cells. So it plays important role in our physiological systems. And this Ganoderma lucidium mushroom have a co-relationship with this gut microbiota. The polysaccharide of this mushroom can regulate the composition of gut microbiota and also can regulate its production of metabolites by this gut microbiota, and can produce the short chain fatty acid, which are involved in many processes like blood cell. It has an effect on inflammatory and immunity. So also the spore of this Ganoderma lucidium supplement mushroom has the ganoderic acid, which act on gut microbiota. So my aim of this study is to investigate the important role of Ganoderma lucidium and play as a healthy traditional medicine for sustain a good healthy lifestyle by modulating the gut microbiota and other physiological indices like blood parameter, anthropometric parameters. And to achieve this aim, the objective are to observe the changes before and after supplementation on biochemical parameter, also the effect of Ganoderma lucidium, observe the Ganoderma lucidium effect on blood parameters, and screening the gut microbiota after this supplementation, and also in vitro anti-sensitivity activity of this Ganoderma lucidium was observed. So for this study, we first collect 150 female college going students, then taking their baseline data like blood sample collection, fecal sample collection for the microbial analysis, also taking their anthropometric measurement, then divided into 3 groups. One is control, treated group 1, which consume 500 mg per day, and the treated group 2, which consume 1000 mg per day. Then observe their different type of data in 15th day and after 30 day of supplementation. For anthropometric measurement, we choose the height, weight, and BMI. For the blood profile, hemoglobin, RBC, WBC, and lymphocyte, and also the biochemical parameters checked by the blood glucose, urea, creatinine, and uric acid. For the enzymatic assay, SGOT, SGPT, and alkaline phosphate are observed. And for the fecal sample analysis, microbial study, we first collect the fecal sample, then microbial study using different types of selective media, and isolate their DNA, and also the in vitro sensitivity activity of this Ganoderma lucidium observed. So the observation is in anthropometric measurement, In case of weight, after 30 days of supplementation with the 1000 mg per day, there is a significant changes in weight. The weight is significantly reduced comparing to the control, but there is no change in height and BMI. In the hematological indices, the RBC and hemoglobin both are significantly increased after the 30 days of supplementation with the 1000 mg per day group. But there is no change in the WBC, but the lymphocyte also change after the supplementation of 1000 mg per day for 30 days of supplementation, but hemoglobin and RBC change in both treated group, 500 and 1000 mg. In the metabolic profile, the urea and creatinine, urea is, there is no change, but the glucose significantly reduces after the 1000 mg, with the 1000 mg per day for 30 day supplementation, but there is a significant increase in creatinine and significant decrease in uric acid after the supplementation for 30 days. In the enzymatic assay, SGOT shows significant changes in both group, 500 and 1000 mg per day group, but in SGPT there is only shows this effect in 1000 mg per day group, but there is no change in the ALP. For the microbial study, the E. coli, total aerobes and the salmonella, which are referred as the harmful bacteria in our gut microbiota, this graph shows that there is a significant decrease after the supplementation with the 1000 mg per day group. In the other side, the total lactic acid bacteria and bifidobacterium, which are referred as the beneficial bacteria of our gut microbiome system. It is observed that after 30 days of supplementation, the beneficial bacteria significantly increase. And these are some selective media which I have used for the microbial study and the gram staining picture of the bacterial cells. Then isolate the DNA from fecal sample, and we amplify the DNA with using a PCR by using the universal primer. And in the antibiotic sensitivity assay, it was observed that comparing to the other antibiotics like amoxicillin, ampicillin, ciprofloxacin, Ganoderma lucidium shows also the resistance power to the lactic acid bacteria and bifidobacterium, and shows its sensitivity to the E. coli, salmonella and total aerobes, which are the harmful bacteria of our gut system. In the apoptotic assay, in the control, we observe that the percentage of the living cell is lower than the treated group, whereas the apoptotic cell are 28.61% present in the control, whereas only 8.62% apoptotic cells are present after the treatment for the 30 days. So after summarizing all this observation, it can be said that Ganoderma lucidium shows its anti-obesity effect by reducing the weight through the gut microbiome, which are some gut microbiota are involved in obesity effect. So by reducing the gut microbiota, some gut microbiota like total aerobes, it can reduces the obesity and weight, and shows this anti-obesity effect. Then by increasing the hemoglobin and RBC, it shows its blood profile effect. I mean, by using the Ganoderma lucidium, it can enhance or boost the energy of individual. And also the apoptotic study, the increased number of living cell and decreased number of apoptotic cell indicate that it has an effect on blood cells and maintain a good healthy blood profile. And also by controlling the enzymatic production, SGOT and SGPT, it has an effect on liver, and the decreased amount of uric acid and the increased amount of creatinine level, it's point out it has also regulating the kidney function. And the most important, the gut microbiome system, it can regulate and the composition of some gut microbiota, like it reduces the harmful bacteria like E. coli, salmonella, whereas it can enhance the number of beneficial bacteria like lactic acid and bifidobacterium. Because the gut microbiome system are involved in digestion, immunity, inflammation, production of enzyme, through this Ganoderma lucidium, indirectly it can involve in many physiological processes. So the takeaway from this study is that using this Ganoderma lucidium, a healthy lifestyle can be lead without using any pharmaceutical, by just regulating the gut microbiome system and involved in many physiological indices. And so it can be used as a prevention of many disease, or it can use for a sustain a healthy lifestyle. So this is a paper, and I am thankful to City College for giving me a chance to present this, and I'm also thankful to my supervisors, Dr. Dilip Kumar Nandi and Dr. Milan Kanti Poida, and also to the my college, Raja Narendra Lal Khan Women's College, and also to the DRDO to providing us this Ganoderma lucidium capsule. And these are some references which I have used for this study, and thank you.
Purna, a very good presentation.
Thank you.
Congratulations. You've done good work. I was just wondering, how did you supplement, how did you provide this Ganoderma? In powder form?
No, in capsules. Yes, in capsule there is a powder of Ganoderma lucidium.
So you prepared the capsule, or you got the capsules from DRDO?
No, sir, ma'am, I'm not preparing the capsule. It's provided from DRDO.
From DRDO?
Yes.
Okay. And, you know, what about, besides providing, did you also control the diet?
No, ma'am, I'm not controlling the diet, but they are coming from the same, I mean, they are coming from the hostel. So they are providing the same type of diet, same kind of diet they are taking. So I chosen the hostel girls for this study.
Any question from students or researchers? Sorry, I'm very sorry to deter you from asking any question. I told at the beginning that any teacher whose student or students are presenting papers or papers, in order to maintain impartiality of judgment and to prevent all kinds of conflicts of interest. এক সেকেন্ড বলে ফেলতে বাধ্য হচ্ছি। আমি বলেই আমি ফ্রি অ্যান্ড ফ্র্যাঙ্ক। আমার ছাত্র আছে, তোমার ছাত্র আছে। আমি তোমার ছাত্রকে একটা কঠিন প্রশ্ন করলাম, ওই কারণে there should be no conflict of interest.
Purna, I just have one suggestion. When you show the gel, you should also show the marker. You just say that this is Ganoderma, this is this, there's a marker. You know, when you show the gel, you should have a marker lane.
Okay, ma'am. Thank you for your advice.
Thank you.
Okay.
Next speaker, Riya Kaur. Examining, our paper is examining the characteristics of marine topse, polynemous species, fish oil, and its potential effects on the high-fat diet-induced Govt BLDC mice model in order to combat obesity. Relax and feel comfortable.
Good afternoon, all the respected teachers and scholar and my dear student present here. I am Riya Kaur, Research Scholar of Midnapore City College under the guidance of Dr. Shravani Pradhan, Assistant Professor in Midnapore City College, Department of Paramedical and Allied Health Science. Today I am here to present a part of my research work, entitled Examining the Characteristics of Marine Topse, which is scientifically known as Polynemous paradiseus fish oil, and its potential effects on the high-fat diet-induced bulb C male albino mice in order to combat obesity. So let's start with the introduction part. As we all know that obesity is a global public health issue where excess fat accumulated in our body. There are some primary causes to developing obesity, like excess food intake, the side-by-side decrease energy expenditure, lack of exercise, slow metabolism, genetic susceptibility, etc. After developing obesity, it leads several metabolic disorders like cardiovascular diseases, type 2 diabetes, inflammation, arthritis, non-alcoholic fatty liver diseases, etc. So there are several drugs are available in the market to reduce the risk of obesity, but we need an alternative way to reduce the side effects of the obesity. So numerous studies stated that sea fish oil could be an alternative way to cure the risks of obesity, and according to Podal et al, we can concluded that the sea fish oil is content of several omega-3 and omega-6 fatty acid, and it had several beneficial effects in our body, like it can reduce the risks of aging, cancer, obesity, inflammation, and side by side improve maternal health, fertility, brain health and development. In this next slide, I summarize the mechanism of omega-3 and omega-6 fatty acid to suppress the metabolic abnormalities by two pathways, activated PPR gamma pathway and AMPK pathway, by reduce the obesity and inflammation. So as you all know that the P. paradises fish is a very common fish which locally found in coastal areas of Bay of Bengal. The main aim of my study is to establish the anti-obesity potentiality of P. paradises fish oil, and to fulfill this aim here are two objectives. At first, extraction, isolation and characterization of marine P. paradises fish oil, and then to search out the anti-obesity potentiality of P. paradises fish oil in vivo model. So these are the concerned methodology which I use for my study. At first we collected the fish from market, then extracted the oil, and after getting the oil, at first we we send the oil for fatty acid characterization by GCMS study, and some part of oil we use for physicochemical properties to confirm that the oil is edible for human consumption or not. Then we design the in vivo model where we taken 24 number of bulb C mice and divided the mice into 4 groups: control group, obese control group, treatment 1 and treatment 2 group. All the groups are contain 6 number of mice, and for first 7 days all the mice are fed with standard diet to adapting the environment. After that, except the control group, obese control treatment 1 and treatment 2 group were fed with high fat diet. And from the 8th week of the experiment, treatment 1 and treatment 2 groups started to co-administered with 2 different doses of fish oil. For treatment 1, it was 20 microliter per 100 gram body weight per day, and for treatment 2 group for 40 microliter per 100 gram body weight per day amount of crude oil. After completion of 12 weeks, we sacrifice the animals and then check some parameters, like we check the lipid profile of the samples, and then staining the subcutaneous adipose tissue and visceral adipose tissue by oil radio and HE staining, and check some gene expression by semi-Q PCR and ELISA assay, and protein analysis by Western blot also done by us. So to fulfill objective 1, here figure 1 represent the gas chromatography and mass spectrometry of P. paradises fish oil. Here the GCMS study clearly revealed the presence of 13 PUFA and 10 MUFA in this fish oil, and here in table 1 represent the in analysis of physicochemical properties of P. paradises fish oil, where we analyze acid value, saponification value, peroxide value and Totox value, and these all the values are within the range according to WHO. So we can confirm that the oil is edible for human consumption. Then to fulfill the objective 2, we measured the food intake of mice in each group for every day. So figure 1A represent that the variation of food intake of mice group, and figure B represent the variation of the weight of the mice for total 12 continue for 12 weeks, and figure C and D represent the variation of BMI and white or adipose tissue weight in all the experimental groups. So significant difference noted in obese control group rather than the control group, and after the treatment with fish oil there is significant changes noted in treatment 1 and treatment 2 group. Then we analyze some lipid profiles and total serum glucose level. Here we can see that cholesterol, triglyceride, LDL, VLDL and serum glucose level was basically high in obese control group compared to the control group, and after treatment with fish oil it was gradually down regulated in treatment 1 and treatment 2 group. More effectiveness noted in treatment 2 group. And as you all know that HDL is a good cholesterol, HDL level was basically lower in obese control group, and after treatment with fish oil it was gradually increasing in treatment 1 and treatment 2 group. Then we check the effect of fish oil on hepatic lipid accumulation. Here figure A, B, C, D represent the liver section of control group, obese control group, treatment 1 and treatment 2 group, and the section was staining with hematoxylin and eosin. Here figure B represent that the in obese control group the enlarged cytoplasm was filled with high amount of fat droplets compared to the control group, and after the treatment of fish oil fat accumulation was reduces in treatment 1 and treatment 2 group. Then we check the effect of oil on skin and visceral adipose tissue. Here figure A and B represent the HE staining of subcutaneous adipose tissue and visceral adipose tissue, and figure C and D represent the oil redo staining of subcutaneous adipose tissue and visceral adipose tissue. In obese control group, we can clearly see that the size of the fat droplets were very high and the accumulation of fat droplets was also very high. In compared to treatment control group, obese control group, treatment 1 and treatment 2 group noted the fat accumulation was reduces and the size of droplets are also reduces in treated group. Then we check some expression of obesity related gene markers which normalized by housekeeping gene GAPDH. Here we can know that leptin and adiponectin are the metabolic regulators. Leptin and adiponectin level was lower in obese control group, and after the treatment of fish oil it was gradually increases in treatment 1 and treatment 2 group, and SIRBP1C and FAS level was decreased higher in obese control group, and after the treatment of fish oil it was down regulated in treatment 1 and treatment 2 group, and as well as LPL and CPT1 level was increases in both the treatment group. Then we check some expression of inflammatory and anti-inflammatory related marker, where IL-1RA and IL-10 are the anti-inflammatory marker. This level was decreases in obese control group, and after the treatment of fish oil it was gradually upregulated in treatment 1 and treatment 2 group. And TNF alpha and IL-6 are the inflammatory marker which increase the inflammation, so its level was decreases in treatment 1 and treatment 2 group. Then we check the expression of leptin, IL-10 and TNF alpha by ELISA for qualitative analysis. So here leptin level and IL-10 level was lower in obese control group, and after the treatment of fish oil it was gradually increases in treatment 1 and treatment 2 group. And TNF alpha, and in case of TNF alpha it was higher in obese control group, and after the treatment it was diminished in treatment 1 and treatment 2 group. And after that we check some protein analysis which normalized by beta-actin, and here we check the expression of FAS, PPR, gamma, alpha and OB. So we can see that the OB level and PPR alpha level was reduces in obese control group, and after the treatment of fish oil it was gradually increased in treatment 1 and treatment 2 group, and PPR, gamma and FAS level was reduces in treatment both the treatment group. So we summarize that the P. paradises fish oil contains several amount of PUFAs and MUFAs, and this oil have ability to reduce the risks, reduce adipocyte in subcutaneous white adipose tissue and visceral white adipose tissue and fat accumulation in liver, and it can reduce, it can maintain some lipid profile in our body. So we can conclude that the oil have ability to reduce the risk of obesity, but in this study we use 2 doses of oil. So between the 2 dose, treatment 2 group is more effective, so we can conclude that 40 microgram per 100 gram body weight per day, this dose is more effective dose. And these are some references which I used for my study, and I acknowledge Dr. Pradeep Ghosh, Director Medinipur City College, to provide us this for nice platform, and Dr. Sravoni Pradhan for her guidance, and Dr. Sudipta Chakraborty, Principal Sir, and Dr. Kuntal Ghosh, Vice Principal Sir, for their advice, and all the faculty members and research scholars of Medinipur City College for their moral help. Thank you.
Ria, very good work,
Thank
good
you, ma'am.
presentation. I really don't have many questions to ask. So did you do all the stuff here?
Yes, yes, ma'am.
In this college only?
Yes, ma'am. Only GCMS study we not done here. We send the sample in Hyderabad for GCMS characterization.
Okay.
This is not available here.
But other histopathological studies
All-
and all, you
all
have
here.
done them here?
Yeah,
Okay.
yeah, ma'am.
Any question from students or researchers? Okay.
Thank you, ma'am.
Next speaker is Raghunath Hajra. He will be presenting his paper, In vitro efficacy of dual drug-loaded liposome with eugenol oleate and amphotericin B against experimental visceral leishmaniasis. আমার বলায়
Good afternoon, all of you. And first of all, I want to express my gratitude to here present honorable chairpersons and respected professors present over here. I am very happy. I'm very happy to present my research work here, entitled as In Vitro Efficacy of Dual Drug-Loaded Liposome with Eugenol Oleate and Amphotericin B against Experimental Visceral Leishmaniasis, under the supervision of Dr. Shantanu Kaur Mahapatro, Associate Professor at Midnapore City College, myself Raghunath Hazra. We know the name of the disease, Kala-jar. Kala-jar also known as visceral leishmaniasis, and visceral leishmaniasis is caused by bite of phlebotomine sandflies, through which Leishman-Donovan pathogen enters the body and affect the several organs. Mostly the patients suffer from the hepatosplenomegaly, which we have shown that the abdomen area is changes because of enlargement of liver and spleen. And many symptoms are suffered from the suffering persons. If we look into the epidemiological status worldwide, then many countries are suffered from this disease, like Brazil, China, Ethiopia, Eritrea, Kenya, Somalia, Sudan. There are so many, and including in India. In case of India, there are Middle Eastern states, Bihar, Jharkhand, Uttar Pradesh, and West Bengal also suffer from this type of leishmaniasis. After they enter the body, the Leishman pathogen, we know activate the innate immune system, obviously. So here the neutrophil and macrophage cells are first line defender cells. If neutrophils are unable to clear the pathogen, then it represents towards the macrophage cells. Macrophage cell uptake the Leishmania parasite, and there are two choices. Actually, there are two choices. If the Leishman-Donovan dominate the immune systems of our host, then it survives within the macrophage cells by utilizing the polyamine synthesis pathway upon the activations of arginase. But if immune system activate or can clear the pathogen, then upon the activations of inos, then activate the nitric oxide, and nitric oxide mediated killing or clear the pathogen from the macrophage cells. From the era of urea stabomine discovery, we know the name of Dr. Upendranath Brahmachari. Till the date, there are so many drugs, sodium stibogluconate, amphotericin B, miltefosine, pamomycin, and all drugs are tested against by delivering liposomal formulations. Among these drugs, liposomal amphotericin B are widely accepted and effective treatment options against visceral leishmaniasis. Simultaneously, the tested also checked combined the drug, but there has not no any single work has been done by formulating the combination liposome by combination drug. So our lab actually trying to explore the efficacy of dual drug loaded liposome against this type of disease. In this context, I would like to mention one immunomodulator role of immunomodulator agent, which has anti-BL activity. Actually, this report from our lab previously reported. Role of eugenol oleate. Eugenol oleate has a significant parasite reduction activity against the L-Donovan infected macrophage cell. And not the new approach, because of liposomal drugs are available. So many available drugs are listed over here, and it is we choose the liposomal formulation because of we can reduce the doses of liposomal amphotericin B, and and it is easily biodegradable, biocompatible, and non-immunogenic compound, non-immunogenic. That's why we choose the liposome. To explore the efficacy of dual drug loaded liposome containing amphotericin B and eugenol oleate against experimental visceral leishmaniasis, this aim to fulfill this aim, our study objectives is preparation of dual drug loaded liposome with amphotericin B and eugenol oleate, and after that evaluate the antiviral activity of dual drug loaded liposome against L-Donovan infected macrophages. And from synthesize the eugenol oleate, we prepare the dual drug loaded liposome and treat it against L-Donovan infected macrophage cells. And from our experimental group, we checked NO generation, cytotoxicity, and parasitemia. synthesized molecule we checked, we characterized by NMR, and this is the figure shown here. Dual regulated liposome will prepare by field thin hydration method, and it is characterized by same images. This is the image. And drug release profile, where the drug entrapment efficacy and drug release study were done by the helping of absorbance maxima of preparing the standard graph of such drugs. Actually, the absorbance maxima of amphotericin B detected at lambda max 415 nanometer, and usinol oleate 350 nanometer are peaked are detected. PPR drug toxicity of PPR drug will be checked. We are checked by MTT assay on the depend of available energy, cellular energy. We know the MTT assay. By which the assay we determine the up to 10 microgram per ml doses can be safe and effective treatment options against the L-domain infected macrophages, and also check the cytotoxic effect of standard drug ambisome, which we get, where we get up to the 1 microgram per ml is non-significant. As I earlier mentioned that nitric oxide can kill the parasite, here our PPR dual drug loaded liposome significantly induces the enogenesis, where in case of anti-amasticode assay, there are when we treated the dual drug loaded liposome, then macrophage cells are activated, and here we got a image of activated macrophage, this one, and we seen that there are reductions number of parasite is significant than other groups. And mRNA expressions of inos and arginase, which is actually counterly regulated. That's why inos activity, which induces the enogenesis, that increases significantly. But arginase 1, who is definitely reduces in this during this experiment. And pro-inflammatory mediators, which are induces the enogenesis, that stimulate the NO productions, IFN gamma, TNF alpha, and interleukin 12 and CD40, which ultimate increases in this in the mRNA expressions of during this experiment. And anti-inflammatory mediators, which are down-regulated the NO productions. These are the interleukin 10 and TGF beta, which that's why we seen over here the decreases during the treatment, the arginase 1 activity decreases. That's why interleukin 10, TGF beta, and YM1 also decreases during the treatment. From this study, we can summarize that the dual drug loaded liposome significantly increases the NO productions, which kill the parasite, and at the dose of 2.5 microgram per ml. From this study, we can say that the synergistic activity of liposomal usinol oleate with amphotericin B may reduces the dosage of amphotericin B in its liposomal formulation. These are my references for during the preparation of this PPT, and I must now acknowledge Dr. Director Sirs in Midnapore City College, and also sincere gratitude to my respected guide, and here principal and vice principal sir also. And we never forget the history behind the discovery of L-donoveni, because of first identify the causative agent by William Boog Leishman. We know the name of the Leishman stain, who discoverer of this stain, William Boog Leishman, and first he identified but can't characterize. Within the 2 months, Charles Donovan identified the same agent. After that, but he during that time he can't identify the causative agent. They are decided to send the sample to the Sir Ronald Ross, and Ronald Ross, by giving the honor of them, given the name L. Donovan. And thank you, all of you. Sorry, sir.
Okay.
Hi, ma'am.
Thank you for your interesting presentation. I just wanted to know something more about the generation of the liposome. What kind of liposome did you generate?
This is conventional liposome.
The conventional liposome.
And prepared by film thin hydration method, where we taken phosphatidylcholine and cholesterol.
So it's a unilamellar liposome.
Unilamellar liposome.
Okay. What are some second generation liposomes? Any idea about the second generation liposomes? These are conventional liposomes, right?
Maybe the targeting anything by PEG additional when the liposome prepare with then liposome targeted towards any macrophage cells, then it's additional or scaffold agent will adding with it. Then maybe the second line of.
No, this conventional liposome you're taking lipid, but for those second generation liposome you're taking archibacterial lipid. Okay, so those are more efficient.
Okay, ma'am. Thank you, ma'am.
Maybe in future you can think of, since you're starting, maybe you can think of taking. So, you have taken unilamellar, these are small liposome, liposomes. Did you ever think of taking multi-layer and this thing? Liposome, do you think there will be some effect, different effect if you take a multi-layer liposome?
Maybe has some effect because of from a paper. Actually, the scientist name Samuel Ripe, most probably, has from this reported, they cited that if the cholesterol significantly increases, the cholesterol are more available towards the macrophage cell, then it can that induces the NO productions or parasite survivability reductions. So if the being instead of use unilamellar, if there are multilamellar use, then here number of cholesterol increases. So maybe it's more effective. But we choose because of our drug targeted towards the hydrophobic region. If there are unilamellar region, then we getting a hydrophobic region easily. Then our dual drug. One is amphotericin B and eugenol oleate. Two drugs are incorporated easily within the hydrophobic region. That's why I choose the unilamellar only.
Okay.
Okay. Any question from students or researchers? Thank you.
Thanks a lot.
Now it's time for Kumar Das. Presenting a paper entitled Anti-Gastric Ulcer Potentialities of Probiotic Lactobacillus plantarum D2 MCCKT, previously isolated from traditional fermented foods.
Can I start? Can I start? Can I start, sir?
Did I ask you?
No, sir.
Are you in a hurry?
No, sir.
Got any pre-engagement? This is a competition, understand?
Okay.
Start right now.
Okay. A very good afternoon to all of you. Myself, Deep Kumar Das, a research scholar of Midnapore City College, Department of Biological Sciences. Today I am going to present my research about anti-gastric ulcer potentiality of probiotic lactic acid, Lactobacillus plantarum E2 MCCKT, isolated from a traditional fermented food. Under the guidance of Dr. Kuntol Ghosh, Assistant Professor and in Microbiology, Department of Biological Sciences, and Dr. Sravani Pradhan, Assistant Professor in Nutrition, Department of Paramedical and Allied Health Science. So let's go on the topic. What is gastric ulcer?
Gastric ulcer is a local and deep necrotic lesion that expand over the entire thickness of gastric mucus and musculus mucosa. The defensive barrier of gastric mucus is associated with the mucous barrier, epithelial barrier, mucosal blood flow and cellular immunity and blood flow. That can be destroyed by taking excessive amount of non-steroidal anti-inflammatory drugs, and alcohol, cigarette smoking and stress, the vital factor that can make an imbalance between aggressive factor and defensive factor, which result in gastric ulcer formation. So there are so many pathways are involved in gastric ulcer formation, and this is probably the one of them. When during stress, our anterior hypothalamus that can directly stimulate the vagal system, which is connected to the stomach, and that can increase the amount of acid secretion and mast cell degranulation, which markedly reduce the amount of mucus. Therefore, our epithelial cells barrier are more exposed to the gastric acid, and then what will happen actually? Gastric ulcer form. So to overcome this problem, there are so many drugs are available in the market, but these drugs have unexpected side effects and lower efficacies. So we need to try to find out a new alternative therapy for gastric ulcer management by using probiotics. So the very first question is, what is probiotics? Probiotics are non-pathogenic living microbes which, when administered in adequate amount, confer positive health benefit to the host. And we know that probiotics are well survive or high survival rate in the gastric juice and adherence to the stomach mucosa. So therefore we can say that the probiotics are well survive in the stomach, and these probiotics can protect our gastric mucosa by increasing the epithelial barrier enhancement and improvement of the mucosal blood flow to the gastric mucosa. And so therefore we aim to study, the study was to evaluate the anti-gastric ulcer potentiality of probiotic Lactiplantivacillus plantarum E2 MCC-KT on a cold induced mice model study. So to fulfill this aim, we have three objectives. Objective one, first one is the cold stress induction to the mice, and second one is the evaluate the histopathological changes of the stomach tissue, and thereafter we will check the gene expression study which is related to the ulcer formation. And to fulfill this all the objectives, we have been followed the following materials and method. First, we have randomly selected all the mice and separate into three different groups. And first group is the normal group, and second group is the positive control, and third group is treatment group. And every group was provided lab-made normal diet with free access of water, but the treatment group was provided probiotic supplement 10 to the power 9 CFP per CML per ml per day. And all the protocols were going on for 30 days. And after 30 days, all the mice of positive control group and treatment group were kept in an individual boxes and placed into the refrigerator for 3 hours. And every 15 minutes we opened the door of the refrigerator for inspection. And thereafter we evaluate the ulcer index, and thereafter we examine the histopathological changes of the stomach tissue, and thereafter we had done the gene expression study by using QRT-PCR. And last but not the least, we had done the relative protein expression by using Western blot analysis. And finally, all the data was statistically analyzed by using one-way ANOVA. And so what we found actually, after macroscopic and histopathological examination of the stomach tissue, we found severe lesions and visible necrosis. This is the visible necrosis over here, and the erosion of the stomach tissue, which is found after induction of the stress. And if we look at the treatment group, there is a very less lesion and less hemorrhagic necrosis after probiotic supplements. So, and this is probably due to the gastric colonization of the lactic acid bacteria that might be activate the prostaglandin E2 secretion, or activate the prostaglandin E2 from the gastric glandular, which might help to recover the gastric tissue. And thereafter, we evaluate the ulcer index of this stomach tissue, where we found that the positive control group had a higher ulcer index than that both. And after probiotic treatment, this ulcer index was gradually decreased in the treatment group. So we can say that the probiotics have the ability to inhibit the gastric ulcer against stress. The percentage of the inhibition was 67%. And thereafter, later we check the genes which are related to the gastric ulcer formation or related to the inflammatory response to the gastric ulcer. Is the interferon gamma, lambda, and IL-12, which is markedly increase during stress in compared to the normal control group. But in connection with the downregulation of IL-10 as an anti-inflammatory substance. And later, alternatively, we check the relative protein expression by using Western blot, where we also found that the PPR alpha is significantly higher in treatment group than that of both normal and positive control group, and in connection with the downregulation of PPR gamma. So, from this study, we can conclude that the probiotic lactic acid bacteria or their metabolite might have the ability to produce anti-inflammatory cytokine as like IL-10, which can suppress the TH1 and that can deactivate the activated macrophage, and it can reduce the pro-inflammatory cytokine expression level. So that's why you can say that during stress our probiotics have anti-inflammatory activity, and they can gradually decrease the chances of gastric ulcer formation during stress. These are the reference for my study, and I acknowledge the first DST and SERB for the sponsor of this seminar, and thereafter I obviously acknowledge Swami Karanda Scholarship, Government of West Bengal, and after then I would like to very much thankful to our Honorable Director Sir for giving me opportunity to research here, and thereafter I would also like to thankful my guide Dr. Kuntal Ghosh and obviously co-guide Dr. Shravani Pradhan, and thank you.
So where did you isolate this probiotic bacteria from?
Actually, I have isolated these probiotics from our locally prepared fermented food.
What fermented food?
Like idli batter, actually. Idli batter, haria, just like that.
Okay, so this one was particular from which one? Lactobacillus, this is the one you isolated, which was from which one?
Haria.
From haria?
Haria, ma'am.
From haria?
Haria. It's a rice-based fermented food.
Okay. And did you characterize it for its probiotic potential?
Obviously, ma'am.
You have not shown, so I was just wondering.
Actually, this is another part of my research, so I can't.
Okay.
Any other question from anyone else? Okay.
Thank you.
One thing, I think you know what I admire is you have put this ethical committee, this thing. Many of you have shown animal experiment, but you have not shown the approval from the ethical committee. He has shown it very well, so that is what you should do. In future, whenever you're working with animal or human group.
Not now. I shall be asking you. Did Sanjay Das turn up? So he has been marked absent. Smita Ghosh. Presenting her paper, Characterization of Aeromonas Infecting Bacteriophage, AHP-MCC11, a new species of genus Afunavirus. You can start.
Good afternoon, everybody, respected professors and here who are present. Today I am going to present a part of my research work entitled as Characterization of Aeromonas Infecting Bacteriophage AHP-MCC11, a new species of genus Afunavirus. I am Smita Ghosh, a research scholar of Medinipur City College, Department of Biological Science. So at first we describe why we focused on Aeromonas hydrophila and Aeromonas hydrophila infecting bacteriophages. Aeromonas hydrophila is a gram-negative dot-shaped facultative anaerobic bacteria which mainly found in chlorinated water, distilled water, drinking water, food, meat, and dairy product. Aeromonas hydrophila is also responsible for a variety of diseases like Aeromonas septicemia, ulcers, arthritis in aquatic animals like amphibians, fish, and other animals including humans. There are lots of antibiotics which are used to combat Aeromonas hydrophila infection like chloramphenicol, ampicillin, tetracycline, etc. Though these antibiotics reduce or lower down the Aeromonas hydrophila infection, but these antibiotics are resistant against Aeromonas hydrophila, and so here in my work I focused on the bacteriophage therapy rather than antibiotic therapy. Prior to the application portion of bacteriophage, whole genome sequencing is needed because in the genome of bacteriophages, the bacteriophage genome may contain sometime virulence or antibiotic resistance gene. This is the aim of our research work, to explore bacteriophage therapy rather than antibiotic therapy against Aeromonas hydrophila infection to protect environment. To fulfill this aim, the objectives are isolation and characterization of Aeromonas hydrophila infecting bacteriophages. Second is whole genome sequence analysis of Aeromonas infecting bacteriophages to confirm absence of virulence and antibiotic associated genes. And third is to check biofilm clearance ability of these bacteriophages. To fulfill this objective 1, the methodologies are isolation and propagation of bacteriophage, TEM microscopic, host range analysis, liquid culture inhibition assay, one-step growth curve, and stability testing like pH, temperature, and salinity. To fulfill objective 2, the methodologies is genomic DNA isolation and sequencing and whole genome sequence analysis and bioinformatics work. And to fulfill the objective 3, the biofilm clearance ability of bacteriophage HPMCC 11 was performed and observed under light microscope. This is the isolation procedure of bacteriophage HPMCC 1. At first, 125 samples are isolated from various parts of West Midnapore, Kolkata, and various parts of West Bengal, and from SUH sample of Midnapore, we isolated bacteriophage HPMCC 11, and this is the plaque morphology of bacteriophage HPMCC 11, and this is the TEM microscopic image of bacteriophage HPMCC 11. Here the head morphology is 56 nanometer and tail is 7 nanometer. This is the host range analysis of HPMCC 11. The purpose of this is our isolated bacteriophage HPMCC 11 could infect other bacteria or not rather than its host bacteria. Its host bacteria is Aeromonas hydrophila MTCC 1739, and this bacteriophage HPMCC 11 could infect Aeromonas C I1 and H2 bacteria, which is also isolated in our laboratory and does not infect E. coli, Vibrio herbae, Vibrio parahemolyticus, and Lactobacillus plantarum. This is the liquid, first is a liquid culture inhibition assay of Aeromonas hydrophila infecting bacteriophage. To check in vitro bacteriolytic activity, we performed liquid culture inhibition assay. When the bacterial OD reached 0.3, that means it's entered the early logarithmic phase, then we add bacteriophage at MY1 and 0.1 level. And after 2 hours of incubation, there is no such regrowth observed. And the second image is the one-step growth curve of bacteriophage HPMCC 11. This is a one-step growth curve, means one cycle of viral growth curve is observed. That's why it's called one-step growth curve. And this is the main phase of this characterized at latent period, rise period, and burst size. The latent period of this bacteriophage HPMCC is 10 minutes and burst size is 22 PFU. This is the stability testings of bacteriophage HPMCC 11 under various pH, temperature and salinity. This bacteriophage could stable a broad range of pH, temperature and saline condition. After genomic DNA isolation of bacteriophage HPMCC 11 in our laboratory, and we sent this genomic DNA to sequencing for NIBMG, and we get a single FASTA sequence, and we used this CGView server for visualization of our genome. This is some putative functions are labeled. Though our genome is linear, for better visualization purposes, we used CGView server. And this is the clans analysis of the bacteriophage. Clans is a bioinformatics tool server that uses BLAST to compare nucleotide and protein sequence databases to a reference sequence databases. Here we used 40 ICTP reported Aeromonas infecting autography variety bacteriophages and NCBI reported autography variety bacteriophages. And here we see that our isolated bacteriophage HPMCC 11 could clusters with HPMCC 7, HP1, CF7 and P2 bacteriophages, which is under also autography VD family bacteriophages. This is the progressive MOVA alignment of the bacteriophage HPMCC 11 with ICTP classified Aphonavirus genus and NCBI reported genus Aphonavirus, and here different colored blocks indicates different genomic sequence similarities. This is the phylogenetic tree analysis of the bacteriophages using major capsid protein and large starbinase subunit. And second is the genomic table of Aphonavirus genus HPMCC 11 is host bacteria is Aeromonas hydrophila MTCC 1739, and we get gene bank accession number is OQ555396, and the genome length is 42439 BP, and GC content is 58.9, and number of CDS is 51. And the highest similarity of HPMCC 11 with P2 bacteriophages is 94.86%. From the ICTP classification, the new genus demarcation criteria is 50% and new species is 95%. So here we say that this is the new species under Aphonavirus genus. And the third is heat map integrating intergenomic sequence similarities, and here the with reference to aligned genome sequence and the genomic length, the intergenomic sequence similarities is also 94%. Here the biofilm clearance ability of bacteriophage HPMCC 11, here we see that the in control slide the bacterial we see the bacterial growth, the bacteria is Aeromonas hydrophila MTCC 1739, and in the treatment slide we used bacteriophage at 10 to the power 9 PFU per ml, and we see that it can significantly reduce the bacterial number. In the conclusion part, we say that the HPMCC 11 is a new species under Aphonavirus genus and under autography variety family, and it has broad pH, temperature and salinity stability, and it potentially scavenge the biofilm, and it can used as a biocontrol agent. These are the some references. I acknowledge SERB board for funding, and our honorable director sir Dr. Pradeep Ghosh, and my supervisor Dr. Kuntal Ghosh, and other faculty members of this college, and my appreciation also goes to the research scholar of Medinipur City College. Thank you.
Thank you for your participation. Now we have to interact with Madam.
I don't have any questions.
No question. Any question from the audience? Is Prashanto Patro present? Pranoti Bera, Prashanto Patro, Pranoti Bera.
Saptorshi Mondal. No sound. Soham Roy. Shubhajit Mohanty. Now it will be the turn for the last speaker. Deepika Das.
Good afternoon to my respected professors and delegates and my dear students. I am Pipika Das, working as ICMR JRF of Biodiversity and Environmental Studies Research Center under the supervision of Dr. Shabuni Pradhan, Assistant Professor in Nutrition, Department of Paramedical and Allied Health Science. Today I am going to present a part of my research work entitled Anti-Obesity Potentiality of Marine Tapra Fish, Opisthophthora staduri oil on high fat diet induced obese mice via regulation of lipid metabolism and inflammation. At first I am going to talk about obesity. In the industrialized world, obesity is one of the epidemics associated with an increased risk of other life-threatening pathologies. According to WHO, more than 1 billion people worldwide are obese. Basically, obesity results from the disequilibrium of energy intake and energy expenditure, and the adipogenesis is the process where pre-adipocytes undergoes early differentiation and terminal differentiation to develop mature adipocytes accompanied by changes in morphology, hormones and gene expressions that can change the pathophysiology of adipose tissue, which accumulate in the different organs, leads to visceral obesity. There are several drugs which are used to control obesity, but they have some inevitable side effects. That is why it is need to develop a potential compound with minimal side effects by lowering other anti-obese commercial drug cost. Till now there is no such work on the fish which are available in the Bay of Bengal region. So the main goal of our study to develop a potential compound using locally available marine fish, and the objective of my study to isolation and determination of fatty acid composition from Opisthophthora staduri oil and to investigate the anti-obesity potentiality of high fat diet induced obese mice and the primary molecular mechanism behind this effect. These are the overall experimental design. At first, male Balpsy mice was randomly divided into two groups. First one is fed with normal diet with water ad libitum, and second one is fed with high fat diet, lard based high fat diet, and after following 12 weeks of high fat diet, the group was randomly divided into three groups with co-administered with different doses of tapra fish oil. That is 200, 400 and 600 mg per dl, and the body weight was recorded weekly, food intake was measured daily, and the liver, blood, subcutaneous and visceral adipose tissue were used for histological and biochemical analysis, and the different gene expression analysis was recorded by PCR and western blot. These are the complete methods, and at first the fish was collected from the seacoastal area of Bay of Bengal region, and the fish oil was extracted by different standard solvent extraction procedure. First, I have checked the fatty acid composition by GCMS chromatography. These are the chromatogram, and this result shows that there are several essential fatty acids which indicate the fish oil has a good nutritional quality. First, I have checked the body weight or BMI, and the visual observation revealed that high fat diet group containing fish oil can significantly reduce the body weight as well as the BMI in different experimental group. Here I have checked the food intake pattern of different experimental group, and in these results indicate that the food intake of normal diet group was slightly lower than the high fat diet group, and after treatmenting with fish oil, the food intake pattern will be slightly reduced than the high fat diet group. Then I have checked the blood biochemical parameters by semi-auto analyzer. Here this result shows that the Opisthophthora starduri oil can significantly diminish the relative triglyceride, total cholesterol, LDL, VLDL and fasting blood glucose level, and significantly increased the level of HDL as well as the total protein level by decreasing dyslipidemia. And then I have checked the liver function test like SGOT, SGPT and ALP level, and this result shows that tapra fish oil significantly reduced the liver enzyme like GOT, GPT and ALP, as well as it can reduce the relative weight of liver. It is the to check the hepatic lipid accumulation, I have done some histological analysis, and the figure shown that mice fed with normal diet, the liver of normal diet group shows dark brown or red color, and high fat diet group were yellowish liver, and the fish oil had recovered the dark brown or red color of the liver, and the many fat vacuoles and lipid droplets were present in the high fat diet group, and the after treatmenting fish oil there was significantly reduced the fat droplets as well as the fat vacuoles. Then I have seen the in the picture the fish oil can significantly reduce the visceral adipose tissue weight compared to the high fat diet in a concentration dependent manner. Then I have checked the HE and oil reduced staining of subcutaneous and visceral adipose tissue, and this result shows that after treatmenting with fish oil, the fish oil can significantly reduce the lipid droplets or the adipocyte size as well as the adipocyte number in the different experimental group. Previous report shows that some marine fish has reported that they may increase the uric acid level. That is why I have checked the urea or uric acid level for renal functioning. This result shows that the fish oil can significantly reduce the urea or uric acid level, indicating this fish oil is did not responsible for the renal dysfunction. Then I have checked the several mRNA expression of adipogenic and lipogenic genes, and the all result normalized to GAPDH. First, adiponectin, PPR alpha, CPT1, LPL mRNA expression was significantly increased compared to the high fat diet group, indicating this fish oil is responsible for the fatty acid beta oxidation as well as to hydrolyze the triglyceride, and the fish oil significantly decreased the leptin, FAS and SREBP1C, which is the central regulator of cholesterol metabolism enzyme like HMG CoA reductase. This fish oil significantly decreased the enzyme production. And then I have checked the several pro-inflammatory and anti-inflammatory cytokines mRNA expression, and the result shows that Opisthophthora starduri oil can significantly decrease the pro-inflammatory cytokines mRNA expression like TNF-alpha, IL-6 and INOS, and significantly increased the anti-inflammatory cytokines mRNA expression like IL-1RA and IL-10. And the protein expression analysis also shows that Opisthophthora starduri oil can significantly decrease the transcription factors associated with adipogenesis like OP or leptin and the FAS expression. Side by side it can increase the protein expression of PPR alpha. Then I have checked the adipocytokine quantification by ELISA method, and this result shows that Opisthophthora starduri oil can significantly decrease the pro-inflammatory cytokines secretion like TNF-alpha and increase the anti-inflammatory cytokines production like IL-1RA. These are the overall experimental mechanism. So this result concluded that Opisthophthora saduri oil can significantly reduce the body weight, BMI, as well as the adipocyte size and number. Thereby, the gene expression analysis also revealed that it can increase the fatty acid beta oxidation by decreasing adipogenesis as well as by increasing the lipogenesis process. These are some references which I have used to fulfill my study. First, I am very much grateful to ICMR for providing me a fund, and I would like to acknowledge to the founder director of Midnapore City College, Professor Dr. Pradeep Ghosh, to providing me such kind of scientific platform, and I am very much thankful to my research supervisor Dr. Shravani Pradhan for her guidance, and the principal and vice principal of this college, and last not the least, I would like to thank my colleagues for their moral support. Thank you.
Good presentation. I was just wondering, you have taken different doses, 200, 400.
Yes, 400.
So what made you take those doses? Is it based on previously published results?
Yes. Because in our previous paper, we already established the fish oil have some anti-obesity potentiality, but these are one dose. That is why I have done in this experiment in a dose-dependent study.
And this dose-dependent study is also based on other published work, not yours, but some other published
yes,
work, right?
Yes.
So you took, what was the reported dose?
Reported dose was 200.
So you have increased from 200, you have taken 400,
400
and 600.
600.
Why did you not try a lower dose?
In our
If
previous
200
study, our pilot study was done, but the lower dose is not effective, actually.
Was not effective.
Yes, ma'am.
I have just two things to say. One thing is that I think all the researchers, for benefit in their future career, before attending or before participating in such competitions, should practice well in front of a microphone. Some of the students was talking very fast, as if he or she has to catch a flight. So presentation is an art. When you talk, you should listen to your own voice first. Speed is very important. I am talking, each and every word is clear and clearly audible. And another thing, voice. Your voice should not be very loud, should not be very low. There should not be any echo. And another thing, Madam has already mentioned, whenever you are presenting any paper on animal model or human subjects, you have to cite ethical clearance. Now, I shall ask, or request rather, Madam to say a few words to motivate the participants for their future life, in brief.
Okay. Thank you, sir. First, I would like to congratulate all the students. I think all of them have given a very good presentation. So it's being a bit difficult for me to, really judge whom to give. I'm saying it's a bit difficult for me to judge because they have all given very good presentation, okay? Bearing, of course, what you pointed out, some of them going very fast, but I can understand maybe it was your very first presentation that they have. Yeah, so practice is very important. Practice, and practice in front of the mirror so that you can see yourself when you're practicing. That's very important. Sir has already pointed what I wanted to say about mentioning the ethical clearance. That is very important. And what I have noticed, I know many of you are from the same lab. So I can see the same kind of work being, presented, okay? So in a lab, we all do the same thing because our students do same kind of work, maybe taking different substance or different substance, whatever it is. What you can do, if two of you are presenting, one can present one part and the second can present another part. Because it's a continuation of this thing, you have different objectives, several objectives, objective 1, 2 or 3. So I've seen many of you, giving the same kind of this thing. So what you can do, maybe one of you present your first objective. If it's a senior person, present your third objective. If it's a very junior person, first year person, you present your first objective. That way you have a variation in your presentation. And that way even the judge knows, okay, it's a different, and it's much easier to evaluate then. Because you are from the same lab, you're doing the same kind of work, and equally you're all very good presenters, very difficult to judge, okay? So that's what I do, because in my lab also we have students, so I ask them, one of you in this seminar, you give this objective, other give the other objective. So that way you have a variation and variety, okay?
Thank you, madam, but 1 more minute. Please, let's cross-check.
I'm just calculating.
Please check.
Oh, whoever has come on, okay.
Priyanka Kaur.
Yes, she's there.
Sangita Maiti.
Yes.
Sahadev Jan. Pratik Ghosh absent. Purna Nandi.
Yes.
Riya Kaur.
Yes.
Raghunath Hajar. Tridip Kumar Das. Sanjoy Das absent. Smita Ghosh. Deepika Das. All others were absent. So you have given the marks. Please sign the paper. You do the needful, then sign the paper and put it inside the envelope so that I can see it.
Just give me some time.
You can leave. And here ends the oral presentation session. Tomorrow, the session will start at 10:30 a.m. There is only one lecture, and then there will be valedictory session, prize presentation, etc. And then there will be birthday celebration.